Hello all. I request the participants to kindly wait for a few minutes. We'll begin shortly. Thank you. Good morning and welcome to the fourth day of workshop on research tools organized by International Center for Advanced Research and Studies. I, Sakshi Gupta, on behalf of the organizing committee, welcome Honorable Speaker Dr. Rinku Dixit and attendees from various institutes. Before we begin with the session, I would be delighted to give a brief introduction of Dr. Rinku Dixit. Dr. Rinku Dixit, you have around 16 years of experience in teaching information technology and advanced technology tools. You are proficient in artificial neural networks, artificial intelligence, Prolog, computer networks, and mobile computing. You are reviewer for IEEE TNNLF, member Internal Quality Assurance Committee, and paper setter and external examiner for IGNOU. You are currently working as an assistant professor at New Delhi Institute of Management. Thank you for joining us here, ma'am. I request you to proceed with your session. Ma'am.
Thank you so much, Smita. Okay, good morning all. I welcome you all to this session, and I'll be giving you an introduction about R programming. And in the subsequent session, my colleague, Professor Shelley, she'll be continuing with R programming and working on a case study as well. So without wasting much further time, let me start with the session. In case you have any questions, you can put your questions in the chat box and I'll be happy to answer your questions. I hope the screen is visible to everybody.
Yes, ma'am. Yes, ma'am.
So let me start off with the R programming. It says R is a statistical programming language. So what is R? R is basically used for all kind of statistical programming, all kind of analytical work. And there are a number of analytical programming languages which are there prevalent in the businesses these days. R is one of them and one of the most popular. And let me tell you, most of the researchers who do their research, they basically do it in R. There are other languages also, such as Python, there is SAS, and every language has its own potential. But R is one of the language which is very versatile, I would say. If you want to incorporate it with Hadoop, you can do it through R Hadoop. You can bring in all sorts of data through R. So let me start with R. Now, there are a number of statistical software. There are command line softwares, there are GUI based softwares, and there are hybrid types as well. The command line softwares wherein we write the commands. So you need to know the syntaxes. All of us are familiar that initially when we started working, there were commands only. So there are commands, you need to understand those commands, remember those commands. And then you can write certain short scripts also. So R also has that command line interface available. But GUI, when GUI came, things became simpler. All of you know that it's better to implement a command rather than write a command. So GUI gives you that interface. You don't have to remember. While you are writing the command, there would be certain instruction. The command would be automatically completed, right? And then there are certain hybrid types wherein we have command line also and we have GUI also. Now, R was originally a command line software, but with certain interfaces which were created later on, the GUI component was added to it, and now it's a complete GUI thing. So you can very well interface with it, you can very well run it, right? Now, these are certain other softwares which are there for statistical working, like SAS, SPSS, SAS, SPSS, Minitab, StatGraphics, S+, and R. Now, where are the roots of R? So R has its origin in another language which was called as R. called as S. S has an interactive environment for data analysis and was developed at Bell Labs.
Sorry to interrupt, ma'am, but your screen is not visible.
Sorry. Is it visible now?
Yes, ma'am. Yes, ma'am.
Okay. So R has its roots in S, another programming language, which was an interactive environment for data analysis. R was developed by Ross Laka and Robert Gentleman, and then they started working on it. So it's basically a team of people who designed R and they started working with R. Now, what are the specialities of the R programming language? Firstly, it is free. It is available as open source, right? It is almost similar to S. S is no more prevalent these days. It's mostly R that people go for. And R is maintained by top quality experts, and it's available in almost all platforms. So you can work on Windows, you can work on Linux, right? And Ubuntu as well. So R is available, and R can work on almost all platforms. And it's a collection of packages. So the core R is smaller, and as per your requirement, you can download the packages, you can install the packages in your system, and you can work on those systems. And this is the website from where R can be downloaded. I'll be helping you out with downloading the R in this session itself. So it's a language environment for data manipulation, calculation, and graphical display. So we mostly relate R with statistical calculation, and the kind of graphics which we can create using R is kind of commendable. And people use R for that purpose only. Because when we talk about any statistical work, what matters is the kind of graphs that you create, because that is what helps us in analytics, right? It's a suite of operators for calculation on arrays, in particular matrices. So you can create arrays, you can create matrices, you can work on matrices. The entire data which can be picked up, which is available, which has to be used, can be incorporated into arrays, can be incorporated into matrices, and can be used. It's a collection of intermediate tools for interactive data analysis. And then we have graphical facilities. So it's a well-developed programming language which has everything. So you want to do basic programming, so you have conditionals also available, you have loops also available, you have recursive functions and input-output facilities available. Now, what R does and what R does not do. On the left-hand side, what R can do, it can handle data and storage. It can handle both numeric data, it can handle both textual data as well. It can do matrix algebra. It can help you with hash tables and regular expressions. High-level data analytics and statistical functions can be implemented using R. It works with classes. It works with graphics. It has all the programming language features like loops, branching, subroutines, and etc. But it is not a database. It is not a database. It can connect to a database. So if you have data available, which is there in some SQL or other such platforms, you can easily bring that database data into your R and analyze it. It does not have any graphical user interface, right? But RStudio provides you that graphical user interface. So we use R with RStudio. R, as I said earlier, also it's a command line interface. So you put up a command or you write small script and you get your results. But RStudio gives you that GUI interface for easy handling of the entire software. R has a language interpreter, which can be very slow, right? It has no spreadsheet view of data, but connects to Excel and MS Office. So you would not see, we are basically used to working on data in Excel, wherein the data is available in rows and columns. So R does not give you that kind of a look, but it can pick up the data from an Excel file, work on it, and give you the results for it. No professional or commercial support is available for R because it's designed by a group of people. It's designed by a group of statisticians who created R for their own help. So there is no professional assistance which is available. but it is very easy to use, and there are lots of tutorials which are available on R, on YouTube, on internet, everywhere, that you do not feel the need of a professional organization to help you every now and then. Now, these are certain graphs which we can use. So there is a package called ggplot2, through which you can create such beautiful graphics. So you can see all these graphs can be made using R. Another example, so you have these box plots and all these kinds of graphics which can be created. So there is another package, ggalley, which can be used for creating such graphics using R. So for everything, there are specific packages which are available, which can be downloaded into R, connected into R, and then you can work with them. Now, who uses R? Now, this is a table which shows me that there are a number of softwares. So people say, why use R? There are a number of languages, and most of the time there is a question that people ask, why R, why not Python, why SAS, why this, why not that? There is MATLAB also available, but R is the simplest language which is there. So you do not have to learn the entire thing. As per your requirement, you can pick up the packages, you can pick up the components that you want to study them, use them, right? Now coming on to RStudio. What is RStudio? RStudio is an integrated development environment for R, right? And it makes working with R easy. You don't have to remember commands. You would be prompted while you are typing commands. There is help also available. You have a specific area where you can write your commands and you can work with it. And it's available as a desktop product also and as a server also. So you can have RStudio in your system, or you can have through server and network connectivity as well. It is free. RStudio is free unless you want the newest version. So there are further versions, the latest versions. If you want to purchase them, you can purchase them. But the basic RStudio that gives you all functionality and all workability is available for free. Now I would like to help you with installing R. I would request all of you to switch on your systems and go to the first website which is listed here, rproject.org. I'll be opening this website myself here and showing you how exactly you can download the R from there. For working on R, you need to first install R and then you need to install RStudio above it. So let's just go there. I'll share another screen now. So all of you, kindly open this website, rproject.org. You may type www.rproject.org, r-project.org. On this, under download, you can see CRAN. On this page itself, you can see all the details about R, right? Now we can download R through one of the CRAN pages. Now what is CRAN? CRAN is the acronym for Comprehensive R Archived Network. Now when we click CRAN, there's another screen that opens up. Now here you can see the CRAN mirrors. Now what exactly are the CRAN mirrors? The CRAN mirrors are the local sites from where you can download your R copy, right? So it's the referral website so that there is no network congestion and your download speed is faster. So as per your location, you can choose. So it would not be beneficial for us to load from Australia, but if there is some site in Asia, we would prefer that, right? So right now I'm going on to this, the O Cloud, Zero Cloud, that is Cloud R projects. When you click onto this, you can see there's another screen that opens up wherein there are three options which are possible: download R for Linux, download R for Mac OS, and download R for Windows. So depending upon your system, you can download. So my system has Windows, I'll be downloading R for my Windows. Now when I say this, so this is opening up and it says install R for the first time. So base, so I can simply say install R for the first time. You can click onto this and this comes here, and the latest version of R is available here. So I can say download R 4.0.2 for Windows is the latest version. When I click onto it, my file starts downloading. So I can simply put it onto my wherever I wish to save it, and the file starts downloading. Now this is a small file. Once this file is there, you can immediately launch this file. You can immediately execute this file and your R gets installed. So once the installer has executed, go on accepting all the options into this. So go on accepting all the options. It will automatically install. Now the setup language, it says choose the setup language. Go on to select the licenses and click on next, and so in my system, it already exists, so I'll not go further. But once you go through it, I would request all of you to kindly install it completely. I'm not running it further in my system, but I expect that all of you would be running it. Now, after we've installed R, our next goal is to install the R Studio. Now, how do I install the R Studio? I'll be sharing another screen. So in this case, for installing the R Studio, the website is www.rstudio.com. So coming on to rstudio.com. So this is the website. When you click onto rstudio.com and you go down, so these are the various versions of software: R Studio Server Pro. So click on R Studio Desktop. So when you go to downloads, so this is your R Studio Desktop, which is free. R Studio Desktop, which has a license fee available, the server, which has further license fee available. So you can click on the first option, that is R Studio Desktop, which is free. So once you click on download, again, so it says you need to install R first, and then you need to install the R Studio Desktop. So choose the version that you want. So Windows 10, 8, 7, this is the version. So you can start from here also. So when you click onto it, the installer would begin downloading. So RStudio EXE comes up. So that also I can immediately run, execute, and my RStudio gets executed. Right? Okay. Now coming back to the presentation. So once we've installed R and once we've installed RStudio, our interface is ready for working with R. Now this is the look of the RStudio screen. So you can see there are 4 tabs which are available. The first on the left hand side top corner, this is where we write our scripts. In the
Sorry to
lower,
interrupt, ma'am, but your browser screen is visible, not the new screen.
okay. Okay, so this is the RStudio screenshot. So on the left hand side, on top is my R script. On the lower side, there is an area where I can run my commands one by one onto the console. On the right hand side, I can see the environment, I can see the history, and lower side, I can see all the graphics which would be created. So this is my RStudio screenshot. Now packaging. R and statistics packaging, a crucial infrastructure to efficiently produce, load, and keep consistent software libraries from different sources or authors. So R is not something which has been completely created in one day, but then it's a growing software. So every time there are newer libraries which are created, they are added into it. So it's a kind of package. Then most packages in the R software deal with statistics and data analysis. So any day there is a new method which is created and we need something new, some new methodologies for working on data, they can be created and those packages can be added to R. And next time when you work on it, that thing would be available for working. And many statistical researchers provide their method as R packages. So it's not that tomorrow, probably tomorrow, one of you can create a package for R, create your own package and give it to R, and that's available for working for people. The R distribution contains functionality for large number of statistical procedures, and this is all what we can do. We can work on linear and generalized linear models. We can work on non-linear regression models. We can work on time series analysis, classical parametric and non-parametric tests, clustering and smoothing. And R also has a large set of functions which provide a flexible graphical environment for creating various data representations. So as I said, we have very good graphics available which we can create using R, and all these statistics is possible through R. And tomorrow if something new comes, so new package can be created, incorporated into R and used by people. Now, these are certain important facts about R as a programming language. R is case sensitive. So if you are writing something in small, it has to be understood in small only. If you're writing something in capital, it has to be understood in capital. So if you create a variable ABC and you put capital ABC, so capital ABC variable name and small ABC variable name are two different variables. So it is case sensitive. Then R is a programming language. Very clear, R is a programming language. We create programs using, but it is a easily understandable programming language. You just need to know certain basic facts, and with the integrated development environment which is provided through RStudio, working with R becomes very easy. The next is R is object-oriented language. So the concepts of C, C++ that we've already studied, in case some of you've done that. So it is an object-oriented language. Then R can easily overwrite the values. R can easily overwrite the value. You've created a variable, given it a value, you again assign it. So the previous value is gone, and R is interactive. So while you are writing a code, immediately you can see its result. So this is my interactive R, where we write a program, where we write our code, there is a prompt which is available. So against that prompt, you need to write your command. As soon as you press enter, the result of the command is visible. Each input expression is evaluated and a result is returned. So whenever you write something in front of the prompt and you press enter, the result is on the next line. Now, what is object-oriented? So if some of you know about objects and classes, what is an object? An object is a variable that consists of certain values, right? And the class is an abstract definition for it. So let me first say, for example, let me go to the next slide. Now look here, I'll go back to the previous slide after this. What is a class? It says a class is a description of a set of objects that share the same properties and behavior. So this is an example which has been given of a professor. So who's a professor? A professor has how do I define a professor? For defining a professor, there are certain attributes that we use. So those attributes would be the name of the professor, the employee ID of the professor, the hiring date of the professor, the status, the discipline that he is involved into, and the load that he takes. So these are certain attributes. Now beneath that, we define, now these are the properties. And now let me talk about the behavior. What are the activities that a professor does? What are the functions that a professor does? So that is my behavior. So every class defines a set of objects, and every object has a set of properties and a behavior to execute. Properties are called as the attributes and behavior are called as the functions that a professor can execute. For example, in this case, it's written that the professor would be submitting the final grades. The professor would be accepting the course offerings. The professor would be setting the maximum load, and the professor would be taking certain sabbatical leave. So there are 4 functions that we've defined for the professor, and these functions can be executed onto all the professors. And now this is a definition of a class. So class is basically the properties and the behavior. Now, what are objects? Every instance of this class professor is an object. So each and every individual professor in an organization would be an object of this class professor. So Professor Smith, Professor Mellon, Professor Jones, they are all objects of the class professor. Now I'll go to the previous slide and say, now look here what it says. Object is a collection of atomic variables and or other objects that belong together. And the context is class gives the abstract definition of the object. Object is an instance, right? And it consists of certain methods, and there are certain slots into an object which are the values. So this is what an object is. So every individual professor that I can see are objects. So moving slightly ahead, if I talk about students, so my class of student would have the attributes which I define for the student, his name, his roll number, his ID, his class, his address and everything. And then the behavior of the students would be the student studies subjects. The student appears in the examination. The student goes for certain extracurricular activities. So all these activities are the behavior which define what the student can do. And what would be the objects? Each and every record that we create for the student class is an object. So my student named Rohan, my student named Sohan, my student named Priya, all these are the objects of the class student, right? So moving ahead. So object orientation, what are the advantages of object orientation? The first advantage is encapsulation. We can use objects and methods someone else has created without having to care about the internals. So if somebody has created a, let's say, object, a class an object, let's say student. Now I need to, somebody worked with professor object, somebody worked with student. Now I wish to create a system wherein I need both student and I need both professor, right? So I don't have to create the same thing again, but I can reuse them, right? So somebody who's already created some things which are already created, I can use them. So the objects and methods that somebody created, I can use it and I can add my own methods to it. So my work reduces. That is encapsulation. Then I have certain generic functions like plot, print. So as I said, every class has certain behavior. So behavior are the functions which I create in the class. So there can be certain generic functions such as plotting, printing, which somebody has created. I can easily use them. Then inheritance. The most important thing about classes and objects is inheritance. I can create a hierarchical organization of complexity. For example, I can create, let's say, organization. Within the organization, there are departments. So at the organization level, I can create a class wherein all the qualities or all the attributes and behavior of the organization can be placed. Within that, I have department. Now, all the properties which are applicable to the organization would be applicable to the child class also. So to the department, everything that the organization has is automatically inherited, and I add certain qualities which are unique for this specific department into this department. So I create a hierarchical organization, and is using this hierarchical organization, all the attributes in the parent class can be inherited and used very easily by the child classes straight away. So these are the advantages of object orientation. And R uses object oriented concepts, has this. Now these are certain math commands which are applicable and which are used in R. So these are certain operators: plus, minus, slash, star, and then we have bracket. These are the standard mathematical operators, and the rules of BODMAS are applicable here also. But to change the ruling, the sequence in which certain operations can be applied, we can always use the brackets. So there is pi. You simply say pi, it gives you a value 3.142. X caret y. So this would give you x raised to power y. SQRT is a function which can be used for calculating the square root. Then we have the ABS function, which can be used for calculating the absolute value of a variable or a value. Factorial, the factorial function can be used for finding out the factorial of a specific number. Then there's another function, log, which provides you x. So log of x using base equal to n. So you can straight away use this function. Log 10 gives you the log of a specific number to the base 10 or to the base 2. Then we have the function exp, which can be used for finding out the exponent of a variable. Then we have all these trigonometric functions which are available: cos, sine, tan, a cos, a sine, and a tan. So all these functions are available. Now R can be used as a calculator also, right? So before I go on to, let me open up R and let's try all these functions. Let's try how to create. And one more thing before I proceed. How do we calculate variables in R? There are three types of variables: numeric variables, Boolean variables, and string variables. And at the time of creating, type is determined automatically when the variable is created with the operator. This is the operator which is used for assigning values to variables. Now let's open up R. Let's open R and try some of these functions. I would request all of you to switch on your R Studio. Now this is the area. You can see three screens You can
Ma'am, PPT is visible, not
PPT.
in your screen.
Okay,
Yeah.
let me close the PPT then. Right. So is it okay now?
Yes, ma'am. Thank you.
Okay, so this is my R Studio screen, wherein there are three screens currently available. I have not opened any new file. So once I open a new file, so the R script, I'll have the same screens that which I showed in my PPT also, which would be there. So on top, I have the script file which is there. I'm closing the script file for the time being. And I will be working on the console. Now this is the area. Now it says type Q and brackets to quit R. Now how do I create variables? If I simply write 2, it will return me 2, right? I create a variable with value, let's say 2, it creates a variable with value 2. I create a variable, let's say B, and I assign it a value 3, it creates a variable by the value 3. Now when I say print the value for B, it simply prints the value 3. A, it prints A plus B, it gives me the value 5. So this is very simple. I can straight away A multiplied by B, it gives me a value of multiplication of the two variables. Now is my PPT visible?
No, ma'am.
Okay.
Not yet.
Okay. Is my PPT visible now?
Yes, ma'am. Yes, ma'am.
So I would suggest that once you've opened up, you can try one of these, some of these things which are there, variables in R, by creating a variable. Had it been an interactive session, I would have seen whether you are able to work or not, but now I can only rely that all of you are trying. So these are certain functions which you can try, 1 plus 1, 2 plus 3 into 4. So basically on the prompt, just write expression and you get the results in the next line. Okay, so I think we can move ahead.
Ma'am, would you like to take questions in between or after the session?
If there are questions right now, I can take them.
Okay, ma'am, we have questions in the chat box.
Okay, let me open the chat box. Okay, the first question it says is less than with minus sign is same as equal to. Yes, it is. Basically, the assignment operator with less than equal to is used as the assignment operator in R. But R Studio works with this also. If it was only R, then the specific operator that I mentioned would have been required. Okay, so somebody says encapsulation with suitable. See, basically encapsulation is putting together the, what is encapsulation? You are trying to put certain data and the methods for working with that data in the same area. So class is an encapsulation of the data and the functions which are required for working on that data, right? So if I say, let's say the example that I gave for the professor, I'll just open the PPT and I'll go back to that PPT. Okay, now look at this. There is a professor. Now, what are the attributes of the professor? I've placed them in one place. Name, employee ID, hire date. Okay, so is it visible?
Yes, ma'am.
Okay. So when I say professor, these are the attributes of the professor, and then the lower side, I can see the functions which can be applied onto the professor. Now, all of you must have worked with C, right? Now, what happens in C? You create certain variables, then you create certain functions, and you keep working with the variables and the functions. Now, you have to remember what variables have been created for what. But when I talk about object orientation, we do not talk about the general oversight, but we talk in terms of object. Now, what is an object? Identify any real world entity. Now, once you identify any real world entity, that entity is described by certain attributes. Now, what are the attributes? The features of that entity. For example, if I talk about an employee, now what are the features of the employee? The features of the employee would be his name, his employee ID, his date of joining, his designation, and his, let's say, basic salary. Now, these are the attributes and the department he belongs to. Now, these are the attributes which are used for defining that entity employee. Now, apart from that, what are the functions which can be applied onto the employee? The employee has certain daily tasks to attain. The employee has certain deliverables to give. The employee is answerable to, has to create certain reports. So there are, let's say, 3-4 functions that the employee is supposed to do. Encapsulation says that put all the qualities of the employee and put all the functions for the employee in the same class. That is encapsulation. I hope my point is clear. Right? So that is encapsulation. Can I? Right. So is my question about encapsulation answered? Kindly just say yes. Okay. Then there is a question, can we use R for wireless sensor network application also? See, wireless depends upon what kind of application do you have. What kind of application are you applying? R is basically used for analyzing the data. So if it's a wireless sensor network and you are wanting to analyze the data of that network, you can definitely use R. The data comes very fast in a wireless sensor network, right? And it has to be evaluated then and there. So we can use R there also. It's basically, R is a statistical programming language. So in a wireless sensor network, if you're trying to find out how exactly are my sensors working, how exactly what kind of analysis do we want, we can always use R, right? So we do time series analysis and we do all sorts of things. R is in category of hybrid now or GUI. R is hybrid. R has both the capabilities available. We have this command line interface also available, and with RStudio, we have the IDE, integrated development, that is GUI interface also available. So R is basically both. Right. The next question that I'll be taking is, can we connect R to NoSQL DB? R can be connected, I can fetch SQL data into this. NoSQL has a slightly different thing. So, but yes, NoSQL data can also be fetched with some modifications into the data. The data can be fetched into R. Concrete class would go beyond the concept, beyond the, the purview of this session. So I don't think we are moving into C, C++ and all those direction. I would like to stick to R because I have certain more content to this. The working of R in command mode again. See, in command mode, as I shared my R screen. Now on that R screen, you start writing the commands. In the next class, Shelly ma'am would be showing you a script. So in that script, there would be specific commands written onto specific lines and she'll be implementing it, right? So once that implementation is clear, your command mode question would be answered. So please wait for some time for that script file to come. And I just now showed you, I can show you this thing. I can, just a moment. Okay. So this is my command line interface. I enter a command. For example, I want to see the sign of 90. And I get my result. This is my command line interface. Similarly, I can write my commands. In the next class, she'll be working on a case study wherein these things would be visible to you, right? So I think I can go, share these slides. Let me see after the end of the session. The session is being recorded on YouTube also. So it's available there. The cases would be picked up. The next, somebody said that please take example or case and explain. The case study would be handled in the next session. So 11 onwards, when Shelly ma'am takes up a session, she'll be taking a case study of HR and doing factor analysis onto it. Right? I think I can move forward now.
Yes, ma'am, please.
Yeah. We're actually short of time, so I'll not be able to take so many things, but then let's move ahead. Okay. So as I said, R is definitely not just a calculator. R thrives on vectors, right? So there are vectors. She'll be working on data structure. She'll be talking about data structure in the next class. And R has many built-in statistical and graphic functions. So the most important thing is R is used for statistics and graphics. Now coming on to reading and subsetting data. How do we read data into R and how do we create subsets of the data? Now, the most important thing is importing data into R. Now, firstly, when I wish to import data, I must have data. Now, I must have data mean where is my data available? Where is my data? The data must be stored somewhere. Either it's stored on my system or I'm getting it live through the internet. As somebody said, through the wireless sensor network. So I have my data which is coming, which is streaming data, which is coming through my network. So either I have a local Excel file or a SPSS file or a SQL file or any other file which is there on my system. Either that is my source of data or I am getting my data through the internet or through any other source like Twitter, tweets, and all sources, all such things. Now, basically, when we talk about data, there are two sources of data. Anybody who works on data, there are two sources of data, internal data and external data. Internal data is always my structured data and external data is always the unstructured data. Now, what is structured and what is unstructured? Structured data is organized data. So when we normally work, for example, if somebody is recording, there are certain items sold in a shop. Now, when those items are sold, there is a proper bill that is created. In that bill, there is a bill number, there are the items which are mentioned, and against every item, there is a cost which is mentioned. So we call it structured data. We are organizing the data under different heads. The item number sold, the name of the item sold, the number of items sold, the cost of the item, and then there is a total amount of the bill. Now, this is organized data. Every organization which picks up the data from the ERP, from CRM, from customers for products, has data stored in Excel or in database, it is called as organized data, and that is internal data. But when we talk about external data, it is all unstructured, right? And unstructured data comes from internet, the transactions, the Twitter tweets, the social media, etc. Now, somebody says that I wish to find out how many people, there is a poll which has happened, and I wish to find out how many people are supporting me and how many people are against me. Now, if I go by the opinion of the people, it would not be yes or no, but there would be certain comments. If I launch a poll right now onto WhatsApp and include all of you, and I put a question, your answers would be all different. Somebody would say, yes, I agree. Somebody would say, I do not agree. Somebody would show me a thumbs up. Somebody would say, I agree with the earlier person. Now, all this data is different. Now, you can see there is no structure to it. This is called as unstructured data. And whenever we talk about analyzing data, whenever we talk about analyzing, right, we talk about both structured as well as unstructured components, right? Now, why is this thing so important? Anytime, anywhere, when we talk about analytics, there are three types of data that we talk about. We talk about structured data, we talk about semi-structured data, and unstructured data. The structured data, as I told you, is all organized, so no need to think about it. You can straight away bring that data into your system, create beautiful graphs and charts, and go ahead. But when we talk about unstructured data, the data which we get from Facebook, the data which we get from chats, YouTube, and all, and so on and so forth, that does not have any face, that does not have any organization. That is called as unstructured data. And in between the structured and unstructured is the semi-structured data. Now, what is semi-structured data? It is half structured and it is half unstructured. For example, there is an organization which wants to find out, let's say there were certain calls which were made to the my customers. And I wish to find out how many people were happy with the services of the organization. Airtel, let's say Airtel conducts a survey. Sir, tell me whether you are happy with the services of Airtel or not. Now, what is that? They would be making a call. So there would be a number which is called up. There is a date on which the call is made, and there is a duration of the call. But during that conversation is a conversation. During that call, there is a conversation. Now, what is a conversation? Certain questions asked and certain responses received. Now, all that conversation does not have any structure. The earlier three things that I talked about, the phone number, the date, and the duration, there is a value I can associate to that. That's structured. But the later part, that is the conversation which happened, does not have any structure. So such data, which is a combination of structured and unstructured data, is called as semi-structured data, right? So whenever we get data, whenever we have to analyze data using R or any other such tool, we always talk about three types of data. Now, what is the problem? Look at the problem. The problem is structured data is very small in size. Unstructured data is more than the structured data in size, and semi-structured data is the largest in size. So size goes on increasing. My size goes on increasing. My structured data I can accommodate in an Excel file, but my unstructured or semi-structured data cannot be accommodated in an Excel file. They cannot be accommodated through a SQL file. I need something else. I need some other handling. So I need certain different type of data structures to handle this type of data. So when somebody tells me in R, analyze my tweets for this question and tell me what is the reaction of the people, I will have to incorporate the semi-structured and unstructured data also and then analyze. So I cannot work with Excel. I cannot work with SQL. I need something else. And that capability is provided to me through the data structures which are available in R. I need to convert all that data through various interfaces which are there, and I need to use it. Now, there's another term which is mentioned here is V's. Whenever we talk about the increasing size of the data, we talk about V's of data, or the characteristics, the varying characteristics of the data. And the four most important characteristics of such huge data are volume, velocity, variability, and value. Volume is this data becomes huge. So I cannot say whether I cannot say that if I'm working with, let's say, 5 MB data right now, in the next half an hour also, it will remain 5 MB. It may become 50 MB. It may become 50 GB. So volume. So there is a huge volume of data. So I cannot rely on a specific system for handling my data while working. Velocity. The data is coming with huge speed. Like somebody said, wireless sensor network. Now my wireless sensor network is constantly on. I'm receiving my data. For example, I'm trying to monitor a parking area. Suddenly there is a increase in the number of vehicles which are looking for parking. So my sensor data increases. The speed with which the data is coming to me increases. Or I launch a campaign. So during that campaign, the speed with which the data would be coming to me increases. Then the next is variability. Now with this data, there is no assurance that the data would remain same. So I can pick up a sample and I'll say that this sample, the results of this sample are applicable for the entire thing. No, it keeps changing. Currently, there is a campaign which is going on. After 1 month, the campaign would change. So my results would change. My audience would change. My participation would change. Right? So there is variability. There is no uniformity in my data. The data keeps changing. So when I'm receiving my data, I must understand it. I must interpret it then and there. When I receive another set of data, I must interpret it then and there. And I should not be associating both of them with each other because they are different. That's variability. And then value. The value of the data keeps changing. Right? It may be valuable right now, but it may not have value after 1 hour. When the campaign is over, my motive is over. My motive has changed. So with this change in the type of data, I have to deal with these characteristics. And while analyzing the data, I need to remember that there are certain characteristics that this data has. So how do I treat it? How do I analyze it to get the maximum benefits out of it? Moving on, issues with type and size of data. So structured data has a definite schema, but semi-structured data cannot be stored in database tables. And unstructured data does not have definite schema or structure, right? So I have to have my handling of the data has to be different. My platform has to be different. Now, when I talk about unstructured or semi-structured data and huge amount of data, I cannot work with Windows. I need Hadoop. I need a totally different interface called Hadoop to work. That would give me the workability. Hadoop is very flexible. It can work with a small amount of data. It can work with a huge amount of data. So starting from, let's say, 5 MB of data to 50 GB, 50 TB, I can handle using Hadoop, right? And why do I need to worry about this? My structured data is very small. It constitutes only 5%, while semi-structured constitutes 5 to 10%, and 80% is my unstructured data. So whenever we talk about analyzing any data using R, my major concern is my unstructured data. How do I get this unstructured content? How do I handle it using my R? So that is my problem. And there I need all the different platforms like Hadoop. And Hadoop can be very easily used with R using R Hadoop. So there is an interface which is available. So you can see what these open source languages are doing today. They are giving you workability and interface with almost every platform that I need for working with my huge pileup of data. Now moving ahead, there are 4 types of analytics: descriptive analytics, diagnostic analytics, predictive analytics, and prescriptive analytics, right? Now, when I say descriptive, what happened? There is certain data which is available, and through that data, I'm trying to describe something. What happened? What was the problem? So I'm trying to describe. That is descriptive analytics. Then my next question is, once I find out what happened, I want to find out why did it happen? What were the reasons behind it? So when I say why did it happen, we talk about diagnostic analysis, right? Now, what is diagnostic? I'm trying to diagnose the problem. Then the next analytics is predictive. I am trying to predict. I have seen certain trends in the past. Using those trends, I would like to predict some trends for the future. That is predictive analytics. And finally, prescriptive analytics. Prescriptive analytics helps me in optimizing, prescribing a solution, prescribing a remedy for the future, right? Now, what we do using R is predictive analytics, right? This is what we do. What will happen? So R is basically, when I say that it's a very good interface for creating graphics, what do I do with graphics? I understand those graphics, understand what is the reason behind it, and I try and make predictions for the future. So there is a graph which is telling me what happened, and there is another graph which I create for the future. That is predictive analytics. And we use R for predictive analytics, right? Now, this is just a glimpse of what these analytics are. Descriptive analytics, as I said, you can look at the example. Google Analytics tool is the best example for descriptive analytics. A business gets result from the web server through the tool, which help understand what actually happened in the past and validate if a promotional campaign was successful or not based on basic parameters like page views, right? So I'm trying to describe, I'm trying to find out why a campaign was successful or why a campaign failed. Diagnostic, for a social media marketing campaign, you can use diagnostic analysis to assess the number of posts, mentions, followers, fans, page views, review pins, etc., and analyze the failure and success rate of the campaign at a fundamental level. So why did my campaign fail? We all try and do it. We all try and do it. Whenever, let's say as a teacher, when I see the results of my student, so then I start seeing that there were 10 questions. Out of those 10 questions, consistently people did not do good in question number 3 or question number 8. So probably there was some problem with these 2 questions. Now, as a teacher with 50 answer sheets in my hand, I can do it. But if I have 5 lakh, can I do this comparison? I cannot do this comparison. I need a tool for doing it. And that tool is all these open source languages which are there. Now coming on to predictive. Southwest Airlines analyzes sensor data on their planes in order to identify patterns that indicate a potential malfunction, thus allowing the airlines to the necessary repairs before its schedules, right? Now, predictive maintenance, it's a popular term these days and almost everybody does it. Now, what is it? There are certain sensors fitted in the industries, and those sensors are giving me certain readings. And I know as an individual that these readings, there is a normal reading and there is what are the abnormal ranges. So as soon as I start getting my ranges beyond the abnormal, I know there is some problem. There is some intervention which is required. This part has a probable malfunction. So then we can go and check for those values. This is predictive, right? So you can see, so with the sensor data, with all such data, let's say in the finance, there is the market. How exactly is the market working, right? Now your market trend is showing you something, but suddenly the trends are changing. Now, while the trends are changing, you start identifying the factors for it. And then you say, okay, if the market is doing this way, then probably this is what will happen in the future. That is predictive analytics, right? by the values which I am receiving through my sensors, I can predict how long would this function. I can also predict that how long I can expect that this component would work well, and beyond it, it would fail, right? That is predictive. And then we have prescriptives. Now, Google's self-driving car is a perfect example of prescriptive analytics. It analyzes the environment and decides the direction to take based on the data. So if there is certain traffic congestion which is expected, so immediately the car would see its GPS, pick up the best route and start moving. If there are cars around, what should be the speed of the car? So all that is prescriptive analytics, right? So with these 4 types of analytics, I can apply them into R. And these are certain domain applications. Sales marketing, we can diversify the target market. We can identify the client needs to increase the response rates. Risk assessment, the area risk assessment, I can identify customers that pose high credit risk. We can see now how exactly, in case you people have heard about this, that there is certain, if there is certain different activity on your card, immediately you receive a call from the bank. Now, do you expect that somebody is constantly monitoring your activity with the card? No. But there are certain expected trends for your card. But if that expected trend is changed, there is an alert which is raised, and that alert, through that alert, a call you receive from the bank side, and then you are able to see, okay, there was a difference in my activity. This is how fraud detection occurs, right? So any significant deviation from the normal behavior or can trigger an event, and we can check. So network intrusion detection, customer care, medicine, all these are applications where we can use analytics, right? Customer care, identify customers likely to change providers, identify customer needs. So all these are my domain applications. So all this is possible using the softwares such as R. And any area that you talk about, finance and logistics, customers and marketing, talent and leadership, analytics is growing. So you must have heard that every job may go down, but the scope for analytics, the scope for AI, ML is increasing with every passing day, be it logistics, be it customer relationship, be it leadership, be it HR, be it anything. So the scope of analytics, the scope of business analytics is increasing. And for business analytics, we need all these softwares to work on. So this is all my unstructured data content, right? And these are certain analytical techniques which can be applied using R. So we can use classification, which falls under predictive. We can use clustering, which falls under descriptive analytics. We can use association rule discovery, which can be used in descriptive, sequential pattern discovery, which is again descriptive, regression, which is predictive, and deviation detection, which is predictive. So these are certain the techniques, the analytical techniques, which can be applied using R. And for all these functionalities, there are specific routines which are available in R. Now, apart from R, there are other softwares also which are used. So platforms, if I talk about, there is a Spark platform, there is Hadoop platform, tools. There are a number of tools which are available, Jupyter Notebooks, RStudio, QlikView, Tableau. Frameworks also, there are TensorFlow framework, which is available, Spark, LearnQ, and so on. Languages, Python, R, Java, Scala, formats, then this is SAS, right? So these are all the tools available. Now coming back to our reading data. Now when we read data into the Excel, I would not go into the details of all these because this is a kind of a checklist. What we need to check while I wish to read my data from my Excel file or my CSV file. Now, I would not be covering this because whenever somebody does it practically, it's more understandable. Otherwise, it's more of a theory. I'll show you straight away the commands which are used. Now, DF is a data frame. So if you have a TXT or a tab limited text file, you can easily import it in the basic R function. This is my function which is used for importing a TXT file, right? So all the unstructured data which is there, it is available either as a CSV file or it is available as a TXT file. So those files can be read into R using this function. So my command, using this assignment operator, I am assigning to a data frame a file. So read.table is my command name. Then I provide within double quotes the name of the file with txt extension, comma, header equal to false. So this is my command for reading a txt file. If you are importing a CSV file, so this is my command for importing a CSV file. CSV file, again, I have read table, file name.csv, header equal to false, and separator equal to. Now, in a CSV file, my records are separated by a certain separator. My separator may be a semicolon, my separator may be a comma, right? So basically the name says comma separated value. So my separator may be a comma or it may be a semicolon. So whatever the separator is, I need to specify with the argument SEP equal to, and within double quotes, we specify a separator, right? Then it says the read.csv as well as read.csv2 function are almost identical to read table function, with the sole difference that they have the header and fill arguments set as true by default. Now, once you start working with this, so all these things would be applicable, and you just need to remember that these are certain things to remember while I am trying to read my data into R. So, and these are the various sources from which I can read my data into R. I can read a SPSS file, I can read a stata file, I can read SAS file from relational databases, from non-relational databases, through TM packing, through web scraping. So all these are the sources from where I can read into SAS. So with this, I would like to end my part 1. I'll take up the questions from here, and details about the data structures in R and one case study would be handled by Professor Shelley in the next lecture. So there is a question which I can see, can we use R for surveillance video analysis? Yes, it can be. I just now said that we can have all streaming data. The streaming data can be analyzed using R. So high speed data, which is there, can be picked up, can be analyzed using R. ERP is enterprise resource planning and CRM is customer relationship management. These are information systems which people use for storing their data, right? So ERP, most of the organizations store their data in ERP or CRM systems. Any questions further?
Participants, if you have any questions, please raise your hand or write in the chat box.
Which is better, Hadoop or Spark? Hadoop is a huge framework. It's a very flexible framework. So Hadoop is much better and depends upon the organization. See, all these tools which are available depends upon what exactly are you looking for. So what are you looking for? What are you wanting? Depending upon that, you can go for Hadoop or you can go for Spark. Hadoop is a very flexible architecture. Any other questions?
Okay, I think, ma'am, that's it.
Thank you so much. Thank you.
Thank you, ma'am. Thank you for your valuable time. Introduction to R would definitely be helping us in carrying out our research work. Thank you for sharing your knowledge and for such an enriching session. Thanks a lot, ma'am.
Thank you so much. Thank you.
I would like to inform that our next speaker, Dr. Shelley, has already joined us. Welcome, ma'am. And here we can have a break of 10 minutes, then we can continue with the session. Please join us again within 10 minutes so that you don't miss out any point. Thank you. We'll start again at 11. Welcome back, everyone. With introduction to R as given by Dr. Rinku Dixit in the previous session, in continuation, we have Dr. Shaili Chaudhary as our next speaker. With immense pleasure, I would like to give a brief introduction of Dr. Shaili. Dr. Shaili Chaudhary, you have around 14 years of experience in industry and experience in teaching IT for modeling and executing business processes. Your area of specialization include business analytics and data science. Your areas of expertise include machine learning, data mining techniques, natural language processing, and big data analytics using Hadoop. You have guided MTech and MBA dissertations title and have published more than 20 research papers in various international and national journals and conferences. You have been a trainer in various FDPs and MDPs in the domain area of machine learning and artificial intelligence. You are a certified trainer of R language, TensorFlow for artificial intelligence, RapidMiner for data mining, and blockchain. You achieved the Faculty Excellence Award 2016 by Infosys. Thank you for joining us, ma'am. I request you to proceed for your session.
Thank you. Am I audible?
Yes, ma'am.
Okay. So let's proceed towards next step from introduction to understanding the data structures, which makes R so flexible in accepting not only structured data but unstructured also. Why we use R, the major focus comes to its ability to analyze the unstructured data set also. Whenever we look for R, we should not look at it from only a programming language which can do basic analysis on the finding a Fibonacci series or finding odd even numbers or something, but it is more or less towards the analytical part of it. Whenever we have analysis given as a project, we should be sure of that we need stats and we need machine learning languages to use it. So now let's proceed to our journey to a data structure in R. I'll take my query once I finish the basic introduction of data structures. All those who are writing their questions in the chat, make sure be ready with the questions, but I'll be answering once I'll finish all the 5 types of data structures which are there. These data structures will help you to understand what makes R so flexible in accepting any kind of data, whether it is structured, it is unstructured, or it is semi-structured, because that's the reason behind why it is used not only for data analysis, but for data science, for machine learning, for big data analytics, as well as for AI. That's the basic to understand. The entire workshop focuses on that. Okay, so let's look at the 5 basic types of data structure we have. The first one, vector. Second is matrix. Third is array. Then we have data frames, and then we have list. Apart from these, we have most important to understand is a vector. Then matrix is very much similar to the way we use, I think those who have worked on MATLAB, they are comfortable with the matrix foundation. Vector is the one which is a sub part of it, a smaller part of it, which is used in, which is executed, which is implemented in R and made a very strong base of R. Then data frame, imagine it as an Excel sheet which we use. The entire Excel sheet we say that is equivalent to a kind of data frame which we have. Then we have list. Those who have studied linked list in C or a Java, this is execution of or implementation or bringing that concept in R. So as you can see, list can include all the 4 things which are given above. It has a vectors also, it has a matrix, it has array, and it has a data frame also. So let's proceed one by one. Now let's come to the vector first. A vector, it is one column or a row of data. Before I proceed, imagine a Excel sheet, because R is basically used for analysis purpose. And entire analysis data, 80% of the data comes from the Excel sheets which we use. So Excel sheet has a rows and columns which are given in a tabular form. Let's say Excel sheet has a roll number, student, and the marks of student in the adjacent columns. So when we take only one column where the roll number of student is given, a one column, only one column, I'm not talking about rows. Databases talks about rows, but R talks about columns. I'm taking only student roll number column. That particular column which I'm taking will be called as one vector in R. Let's read the description. One column or row of data. We always give a same data type. If I'm writing a student roll number, it will be numeric. That's why we say it can be only one type, either numeric, text, or Boolean. If it is Boolean, it will remain Boolean for the entire column. If it is text, let's say student name, then it will remain a text for the entire column. So the column which we talks about is a vector in R. It's not the vector which we use in mathematics. It's one column. You can imagine it as a one single column which we use in R, which we use in Excel, and named as vector in R. Then we have matrix. It is multiple columns and rows of data. So it can have one type. It can have again one type, either all numbers or text. Then we have data frame. Data frame, imagine not only a one column, but the entire Excel sheet. In the first column, we have roll number of students. In the second column, we have name of the students. In the third column, we have percentage of students. So we have multiple data types, which has numeric also, text also, there can be Boolean also. So multiple column and rows of data is having a multiple data types is data frame. If I pick just a single column of a data frame, that refers to as vector. Fine. So these are the basic building blocks of R. In the next slide, I'll be explaining how each one of them. Okay. Let's take R vectors. It is a series of numbers. It can be created using a small c. C means combine. It can be created using a next element called as term called as rep. That means repeat. Then you can create a sequence from M to N. Most mathematical functions and operations can be applied to vectors without loops. All those who are comfortable with loops concept in C, C++, Java, this is the most surprising zone for them, that R omits loops to a great extent. Unless and until you deliberately create a loop, it will help you out in removing that or executing the same application without using loops. Okay, now let's have a look at how we define vectors. The very first one, repeat 1 10 times. Rep, that is a keyword. We are repeating 1 10 times. In a second, we had three keywords through which we can create vectors. First is rep, seq, sequence, and third is C. So first rep example is from 1 to 10, you're creating a sequence. Then you can creating a sequence from 2 to 3. Then you are creating a sequence from 4 to 20, but with the gaps of 4. Have a look at the sequence which is created 4, 8, 12, 16, 20. They have a gap of 4 in between. So now let's look at how the first vector is created. You can have a look at X. We can use equals to sign. Then again this sign, which is just written after X. This is also an assignment operator in R. Here we have created a vector which has a value of 2004 saved in X. Again, we have a vector which has a value of 1999 and saved in a vector named as Y. If we'll say X plus Y, have a look at the answer. This is the sum elements of two vectors. The two vectors which we have created, one is X, second is Y. Then we have multiply. We can multiply in the same way. We have the basic operators which we are using on it. Similarly, is a square root function which is shown here. To access the elements from the vectors, we use operator, which is a bracket operator. Fine. And to select a specific element, we have the indexes. Similarly, the way we use in Java, to exclude a particular element, we use negation symbol. That means if I don't want to include first column, I can say -1. If I don't want to include eighth column, then I can say -8. Have a look at this. We created a vector named x, which has a value 2004. And when we say that we are only referring to the first element of the vector, we are simply saying x1. That means we got the index value of 1, which is the value is 2. But when we say -1, that means everything excluding the first element we received. Then we said replace the first element to 3. Then in the next one we said replace every element except the first element to 5. Next is the comparison of each element which we have done, which returns it as a vector. When we say in the vector y, whose values were 1, 9, 9, 9, compare it to be less than 9, then we got true and false for the rest of the elements. Then if you want to derive, then we say that fourth element of the vector y, convert it to 1, and then we again looked at the comparison of it. Then again we got the different answer: true, false, false, true. So that means the vectors are the first building block for the R analytic zone. Let's define it. A vector is a collection of elements, most importantly of the same type. It cannot be of mixed data type because it refers to the one column which we pick from R. Which we pick from Excel. If your Excel sheet has 10 columns, then it will come into R as 10 vectors. Vectors don't have dimensions. That is, there is no such thing as column vector or row vectors. These vectors are not like the mathematical vectors where there is a difference between column and the row orientation. Now let's look at the example. We have a first vector. I have not given a name to it. That means it's not been saved. It's just created. We have used a keyword C, which means combine. And the elements which are there in the vector is 1, 3, 5, 7, 9. Then we made a character vector. Most important thing, just look at the quotes when we are writing a character vector. So C stands for combine because multiple elements are being combined into a vector. Let's look at the example. We have a variable named as first underscore vector, in which there is a sequence from 1 to 7 and again one more 7 saved in the first vector. Main point of vector, the operations are applied to each element of the vector automatically without the need of loop throughout the vector. This is the most powerful concept and one of the greatest thing about R. Have a look at this slide in a very comfortable way because this holds a very strong background of why to use R. Those who are programmers of C, C++, Java, or any other platform, they'll be able to understand the importance of this particular function which we have given, that no loops required. Have a look at when we have created first vector and we simply wrote first vector multiplied by 3 and we got the exact output. There is no looping required, no check for the end element, number of elements, nothing like that. You'll have to simply write the operator in between. And if you want to create sequence, these sequence are also vectors. As we discussed earlier, that we can use C, we can use SEQ for sequence, and we can use REP for repeated. So let's have a look at when we write 1 to 10, because there is no variable name given to it, so it will not be saved, but the sequence it will create is from 1 to 10. If you write 10 to 1, it will create a sequence from in the opposite one, -2 to 3, 5 to -5. Let's look at the operators. Again, the same. We don't need any loops to be created. We created two vectors. using a sequence operator. We have used a colon in between. We have V1 where we have a length of the vector is 10 because there are total 10 values given to it. So 1 to 10 is saved in V1, vector 1, and -5 to 4 is saved in vector V2. If you find the length, just have a look at the length function because we will be going in a little fast mode. So I've given functions in between the slide rather than taking a special lecture of the various functions which R has. So have a look at the length function. It simply gives you the exact size. If I'll say length V1, it will give me 10. So let's look at the operations on these two vectors. If I'll say V1 plus V2, it will be added sequence by sequence. Similarly, V1 minus V2, multiplication, division, all these operators, no loops required. This is a language for analysis. So whenever you work on this, you'll find there are very flexible zones which R has defined, but it has the disadvantage zone also, which we need to address when we are working on it. Let's imagine an Excel sheet where you have two columns of which refers to the marks students achieved in two subjects, let's say science and maths. In maths, the number of rows you have entered is about 10, but in science, the number of records you have entered is 12. So there is a mismatch. In maths, the number of students whose marks are given is 10, whereas in science, it is 12. But R facilitate this without giving you any error message, just a warning will be given. Those who are already a programmers, they'll be knowing it will be a big deal when you handle such kind of situations in Java or C++. So let's look at this side of it. When we say that R is flexible, flexibility also has a cost. We need to look at that we are operating on two vectors which are not of equal length. How R is working on it. When operating on two vectors of unequal length, this is a very favorite question of any interview of data analysis which you face, that how R facilitate unequal length operations on vectors. Have a look at the note below. The shorter vector gets recycled, that is, its elements are repeated in order until they have been matched. Until they have been matched up with every element of the longer vector. If the longer one is not multiple of shorter one, a warning is given. Let's have a look at the example. We have a C, that is, we have a C operator which is used, and the vector X has a sequence from 1 to 10. When we said X plus C, one more vector whose name is not given, but it has only two elements given to it. Have a look at how the addition is how the addition is performed. Let's have a look at when 1 plus 1, in a second sequence, it is 2 plus 2. And for 3, it is again 1. For 4, it is 2. For 5, it is 5 plus 1. For 6, it is 6 plus 2. For 7th element, is it 7 plus 1. For 8, it is 8 plus 2. For 9th element, it is 9 plus 1. And for 10th element, is 10 plus 2. So there is nothing left. The entire two vectors are executed comfortably, no error prompted. Whereas in the lower one, when we again say that we want an addition operator to be performed, in the first vector X, where we have 10 elements, where the size is length is 10, whereas in the second vector, we have the size is 3, which is not a multiple of it. Have a look at this. One will be, the first element will be added by 1, the second element will be added by 2, third element will be added by 3. Similarly for 4, 5, 6, 7, 8, 9. But 10 and the 2 from the second vector, 2 and 3, will be left. That's why we'll receive this warning sign that longer object is not a multiple of the shorter object, but it will be executed. There will be a warning sign, but it will be executed because R believes in flexibility. It will not stop on every second error which you do. It performs a lot of activities just on a background. That is, we are not writing anywhere in char, which we used to write in SQL, which we used to write in Java, C, and data type seems to be a big deal in all the programming languages. Then where all those are given, I'm not writing int x is equals to this. Where is that gone? Because OR is automatically doing that part. It takes the data and it decides it itself. It's R's job to decide on the data type of it, depending on the data which you have given. So let's look at the vector comparison. It's very similar to the one which we have done. For a vector X, we have made a comparisons and the other outputs are given. Whereas in the second one, we are comparing two vectors. Similarly in and all also. Okay, now let's look at the individual elements which we retrieve from vectors. When we say X with the index of 1, we retrieve the first element. When we say vector X with the index 1 to 2, this is a different feature which we have. We retrieve first two elements. When we say we retrieve the combination of first and fourth element, we get 10 and 7 as the output. Naming of the vector elements, we can name the elements. Let's say if we are retrieving the data from Excel sheet and we want to name it, the names function is used. This is another important feature. That means whenever we use R, we have another important feature, that is factor vector. These are important concepts when building models. Let's say we have created a vector whose name is Q, where the data which is given is hockey, football, baseball, and the other things. That means in total, the length is 10. So length is 10, whereas number of characters in each, let's say in hockey, the N char will be 6, whereas the length of Q will give me the 10 as the output. So have a look at this query. In the first one, we created Q with the length as 10, whereas we created a Q2 and we incorporated the first one Q in it, and we got the total length of 16. Let's have a look at the few points which are written on the adjacent on the right hand side of it. First 7, 1, 7, 13. It may be different on your screen, because depends on the font size. This is the row number, the value number of your analysis. So let's have a look at the levels. Whenever you have factors, these factors are given as levels. That means all the unique values are being given as the levels. Everything which is repeated will not be repeated in the levels. Have a look at the Q2 factor. Whenever we convert it as a factor, we have hockey, football, baseball, in which we have hockey repeated, I think, twice, and football is not repeated. Hockey is repeated 3 times, but this will be given as only one level. Whenever we create a factors, the levels which we have makes it more unique. Only the unique integer type is given to it whenever we write it. So let's look at the one function which will called as factor. Normally it will be saved as a character vector in your R, but we can create it as a factor which will give it a unique number. Rather than saving the values, the exact names of the people, we can save it as a unique levels, which is a unique integers. Now let's come to data frames. You can imagine it as a complete Excel sheet. It is one of the most cited reason of R ease of use. Your entire CSV file, when I say CSV file, you can say comma separated files, which is usually been created to keep our contacts saved in our mobile apps. So all those can be easily retrieved because all these can be easily retrieved because we have a feature of data frame. Whenever we were talking about vectors, we were talking about a very small unit, but whenever we talk about data frames, we are talking about complete Excel sheet. Just like an Excel spreadsheet, rows and columns, in a statistical terms, each column is a variable and each row is an observation. In R, each column must be of the same data type like vectors. Let's create data frame. So we have one vector as X, another vector as Y, and third vector, which we have already created as Q. And we are creating a data frame 1. For this, we'll use a keyword called as data dot frame, in which we have included first column as X, second column as Y, and third column as Q. And the most important part is the length of all three of these is 10. Have a look at it in another way. In the lower one, we have given names to them also. In the first one, the same name through which we created our data, we created our vector is been shown as X, Y, Q. Whereas in the lower one, we have first, second, and the sports given as the major one, as a names. Or we can say that when first is equal to X, that means the vector X has been renamed as first only to be shown in the data frame. So for a data frame, we have three main functions: number of rows, number of columns, and dimensions. Let's say we created a df1. N rows means number of rows, n col means number of columns, and dim means dimensions. Rows and columns both, 10 and 3 both are shown. Okay, we are going ahead of it. Let's have a look at, if you want to retrieve, let's say you have a complete Excel sheet and you want to retrieve only one column. For that, you'll have to simply write the index of that column. Similarly, we did in the vectors. Have a look at the fourth command, which is written df1, and in brackets, in the square brackets, we have 3. That means the column number 3 is been retrieved from the data frame. Similarly, you can pick any value out of it. Let's say in a last one, we have picked df1 row 3 from the column number 2, and we got the value as -2. Similarly, data fetching goes on, and in the second command which is given, it is an important one. In the third row, pick from first to 3, pick all the columns of the third row. Then in the df1, we said combine the third row and the second row of the C, that means second column. This is just a review. You can just go through it so that we can move ahead. These were the two basic data structures which make R a very strong data analysis language. First, we did vectors, then how to access the vector elements. And let's go to a very small question round, which is usually been asked by the companies whenever they look for a data analysis, data analyst professionals. So have a look at this. When I say is numeric, is 1 is saved as a numeric because R says everything automatically. To change a number to an integer is a big deal. For that, we need to write a capital L. If I say that I have saved one as a numeric or not, it will say true. Yeah, it's been saved as numeric, but it is not been saved as an integer. But if you want to save it as an integer, we'll have to put a capital L just behind it. I'm reading the narration part of it, the explanation part of it. R handles the difference between the numerics and integers for you in the background. Putting capital L after an integer forces it to be stored as an integer. Now let's look at the different parameter, different data structure. First we did vectors, then we did data frames, and now let's move to another one, list. Those who are in a data analysis, like in the earlier lecture also, I've seen a participant who asked for surveillance. There is a package for it, but whenever you look for a data which is in a tree-like structure, that means complete hierarchy is made. For that kind of structure, we use lists. For a normal predictive analytics, we use data frames or vectors, which is a smaller part of it, but list is a complicated part of it. List is a data structure R uses for complex and any object, any study which is strongly in a hierarchical form. Like if you are comfortable with data mining techniques, a decision tree is a big example of how the list is used. Whenever we take any loan from banks, so there are lots of clauses which they talks in between. They all are being checked, like your age, your earning capacity. There are, let's say if you talk to a manager, he'll give you about 15 to 20 conditions which needs to be satisfied. This kind of interlinked hierarchies are considered in list. Our data structure for one-dimensional object, apart from vectors, it's a list. It extends the idea to model objects that looks like trees in our real life. Let's have a look at this. In X1, we have two vectors. First vector has two components, two elements, 1 and 2, and the second vector has 3 and 4. So X1, the keyword which is used here is list. In the second, we have two lists in between. You can look at the diagram which is shown. In a third one, we have one vector, then we have a list, then we have a second vector and the third list again. These are the complex zones, the complex analytic zones. So when we create a list, in this, wherever a list command is used, you will see a double square brackets. The list elements will be shown as double squared. You can see, have a look at the 1. Then again, the first element is written as 1. In a second element 2, the first element is again 2. In the third, we have third element in which a first element is 3. Whereas in the lower example, the entire vector is given as a first element. So we use a simple keyword called as list to create it. We can name it. Whatever we have created so far are df1, which was a data frame. Then one more vector 1 to 10, or there's a simple naming condition that you put a is equals to sign and assign a value to it. It will name it. Then the next part of is matrix. Those who work on MATLAB, they are the most flexible candidate for this data structure because they are comfortable in working in a two-dimensional data structures. So this is the two, apart from data frame, we have matrix as a second two-dimensional data structure. It is similar to vectors, but additionally contains a dimension attribute. All the attribute of an object can be checked with the attribute function. Dimension can be checked directly within the dim function. We can check if a variable is a matrix or not with a class function. Even for vectors, for data frame, for list, you can check how it is saved in the background using a class function. It is a very common mathematical structure that is essential to statistics is a matrix. It is very similar to data frame. It is a rectangular with rows and columns, dissimilar to data frames. Yeah, it is not similar and not exactly like a data frame, that every single element, regardless of the column, must be of the same data type. It is similar to vectors in a terms with element by element addition, multiplication, subtraction, everything which you do on matrices, that can be easily done, just like vectors. Functions like n number of rows, n col, number of columns, and the dimensions can be used. Let's have a look at how the matrix is created. Keyword which is used is matrix, where we have created a value. The data to be entered is 1 to 9, and number of rows defined as 3, and number of columns defined as again 3. By default, a matrix is stored in a column major orders. As you can see on the screen, the matrix which is created, which is named as saved in a variable named as matrix 1, is filled in a column order. 1, 2, 3. Then we have in a second column 4, 5, 6, and in a third column we have 7, 8, 9. But if you want to change it, then we can say that by row is equals to true, just shown in the last example, which is shown in the last example. And the most important thing is to note, please write true in a capital rather than writing true in a small one, because it's a keyword. Just the way we used to name in data frames, list, and in the matrix, it's the same procedure which we follow. We simply give the names and we use a small function called as names. We can give a names to the rows and columns separately. Accessing the elements, very similar. The way we used to do in data frames, similar one. Let's have a look at, we created a matrix which is saved as matrix 4 with the name matrix 4. This is the output which we get. We have 3 columns, we have 3 rows, and if we say matrix 4, 2, 1, that means the row number 2 and column number 1. Fine. It is to be changed with assigned a value 20. Have a look at the second output. And in the similar one, we can have a look at the example where the operator, comparison operator is used. Okay, now let's have a look at let's execute them in the RStudio. Is the screen visible to all? Our
Yes, ma'am.
screen? Yeah?
Yes, ma'am.
Okay, now let's have a look how we really execute them. Before I start with typing in, I just want to make a small revision one. First, we studied vectors. Vectors, one column, one data type. Exactly like one column in Excel. Then we have matrix. Fine. Then we have arrays. Arrays is the one which is a part of matrix, which is not usually used in a very basic analysis of, let's say, business data sets. Whenever we have a weather forecasting data sets, then only the arrays are used. Then we have data frames. Next most important concept in today's class, data frame, when we have, which is in a form of a table. When we have rows, we have columns, and we have dimensions, because it is a two-dimensional diagram. Fine, and it can hold multiple data types in each vector of it. Then we have list, which is a complex structure, very similar to the trees which we use in our real life, or in other programming languages, linked list which we use. Or you can say linked list when we use it in C and C++. So let's execute the very first one. Here I have created a X. Let's say if I write C, and if I write 2, 3, 4, fine. To execute it, there are two, okay, there are 4 screens to it. Let me explain the screen first. There are 4 screens to the R. This is your environment variables. This is your history, whatever work you have done so far. These are your connections. Any connection, like I've seen that many students ask for NoSQL and SQL database connections. Yes, you can do it from this area. Have a look, ODBC connection, Spark connection. I think there was a query about a Spark in the last session. Spark is a part of Hadoop family. Fine, and ODBC means you can go for any SQL data set, or any kind of database connection can be easily done from here. So these are the connections, this are the environment variables, and this is the history. When I'll start working, I'll show you how the changes are happening here. Then this is the second screen where my cursor is at present. Let's look at the files. These are the basic files which I've used in, let's say this is today itself, I checked this file. This is the same file which I'm using at present. Then these are the plots I've created. Whatever diagram, whatever analysis, visualization diagrams you will create, that will be shown here. Packages, one of the strongest feature of R. Let's say, for example, we have Android phone, we have iPhones, we have iOS phones at present available. Let's say we'll say XYZ comes into market tomorrow, and I need to fetch the contacts from that. How will I do it? R is an old language. How will I get that? How will I facilitate that? For that, I'll get a package from the R Society. To install that package, just go to install, type in, you'll get that reference here, and you can install it. The moment you'll install a specific package, it will start working. Your R will start facilitating that particular feature. I'll give us some example from something which is very close to us. We usually go for, say that in a COVID-19 era, we all have analyzed the emotions and the fear or anxiety which is there in a society. How we analyze that? Let's say from our tweets and Facebook accounts, we fetch the data. How to fetch? That package will be provided from here. The Facebook itself will provide you a package that can be incorporated here, and the data can be fetched. Similarly for a Twitter accounts also. So whenever new things come, it comes to R as a package. The organization, the basic platforms which we use to connect are the packages. Fine. Then we have a help. Fine. This help is about anything which is already given, all commands, all structures. As you know, in all languages we have help. So next two important screen. The lower screen is this particular screen is a terminal. When I say 2 plus 3, and I say enter, only enter I have pressed. Have a look at, there is no change in my environment variable. Nothing is being saved. But if I'll say x equals to 2 plus 3. So you can see that x is here. So we have environment variable, x has been saved as 5. Those who are comfortable with the programming languages, for them, it is just like a variable declared and saved. We need not specify the data type here. That's a flexibility of R. Fine. So we have x, which is saved as 5, which is saved as a vector. Fine. And you can write the same command. So I'm just omitting this equals to sign, because wherever you will find a professional answers to a question, you'll find a different assignment symbol. Have a look at here. And to view the same, it's the same one. Fine, so you can use two assignment operator. First is equals to sign, then there is a combination assignment operator, which is used specifically in R. So let's come back to our first screen. Okay, this is the console, but this is my file where I can save. To create this file, go to file, say new file, and say R script. You'll find this new file coming. Let's say you type in something and then you press this save. It will ask you for a location where you want to save it. So whenever you want that your data will remain with you, that time create a file. Otherwise, this data, this particular way, this will be only in a command history, but will not be saved. The file you are just looking at, which is named as basic ICARS, that is a saved file from my side. So let's come to the very first one, that is a vector. Let's create first vector. Our vector name is x1, which is a variable name, and it is a vector because we are using a small keyword called as c. Okay, so it will have a 3 values to it. I'm executing. To execute a command from this screen, that means your saved file. Here you'll have to use only enter, but here you'll have to use a combination of control and enter. It's been executed. Again, I said control and enter. And now just have a look at my environment where one more variable, which is of numeric type, is been saved, and it has 3 elements. I think all of you can have a look at the screen. First, I created a normal value, which is x is equals to 5. Then I created a vector. There is a big difference in the display out here. Vector name is x1. It is a numeric one, and it has 3 values. All 3 values are shown there. If the space allows, it will show almost all. Have a look at the class, how it is saved by R. As I told you, the background, it will save it. Fine, so it is saved as a numeric class. Okay, to create a sequence, we have created x2. Let's have a look at x2. Fine, it created a sequence of 1 to 5, and then finally one more element was added, that is 99. To repeat the values, we use rep. Fine, and let's have a look at x3. It is repeated, 99 is repeated 5 times. Okay, now let's have a look at the character vectors. We need to have double quotes for it. Then an important one, length. Length of it is 4. We have 4 values in it. 4 elements, that means 4. Now let's have a look at this. If you guys want to try, for this, what will be the output of this particular command? Let's say this is the kind of questions which we get in our recruitment processes. Let's say you need to predict. It has been saved as complex. We have I, a separate term, which is given to 2 plus 3i, which is a term which is not yet defined. That's why it's been saved as complex, but not defined by our side. We have not decided, we have not told R to save it as a numeric or an integer or a character or a factor. It's been saved automatically. That's what a zone of R which we respect it for. Because it will not give you a burden, it will start understanding. Whenever you write a command, it will start understanding how to save it. Have a look at this. Here we have a complex number plus a text number also with us. Because as we have given a RAM on the last one, it has taken it as a class. Let's have a look at how it is being saved. The entire is being saved as a character. They all are in quotes. Now have a look at this. We have created a sequence. Now let's have a look at the sequence. It's integer. Fine again. So these are few examples you can look at. Okay, one more question. Those who says which kind of R, what platform you have used on R. So this is the R version at present I'm using. I'm using the latest version of 4.0 as given as the instructions given by Rinku ma'am. I think the latest version at present which is available there in the market is R 4.0. If you will say, install it today, you'll get the same version. So let's look at the operators on R. So we created a two vector called x1 and x2. Fine, and have a look at the output. Okay, no loops required. Most important to understand, there is no loop which I have taken for x1 or x2 where the index of the last element has been taken, noted, and the operator is executed till we reach to the end of the file. Nothing of that type. Fine. So when we say x1 x1 plus 2, that means all the elements of x and are to be added with 2. It's so simple. Then we have a recycling one. This is the one which which we discussed in a presentation about the unequal length. Let's say we have a x1, we have a x2. We have a x1 plus x2. Fine, so we got the warning sign, but it is being operated. It is implemented for you to have a look at the two files had uneven length, but it will be executed. It will not stop. Fine, this has also been executed. Definitely you will get the answer with the warning sign. The reason behind such flexibility, as far as I think, is its ability to talk to different types of data. If you are very strict about your rules and the norms or procedures, how to save the data sets, you'll land up in your inability to solve different parameters of questions. So I think that's one reason why R has been created in such a flexible environment. So when I say C1 plus C2, here we have one as a character and second as a numeric. So here you will get an error. For logical error, definitely you will get a error. So let's look at for C3. Here it's been executed. So let's look at C3, which we have created just now. That means this. If I'll pick a vector index value 2, what will be the, this is a fetching, how we retrieve data. Similarly, we have matrix also. So let's have a look at, we create a matrix M1. This is the matrix created. We create a matrix 2. This time we created by rows. That means the first one M1 is created by rows is equal to false. That means false, as that means it's been saved in a column basis. The data has been taken as. But in the lower M2 one, we said by row is equal to true. That is the reason why data is being kept in a row wise. It's been saved as a row wise. So again, we have a look at M2. When we say it's false, the entire look will change. Fine. So this is the how we retrieve data from. This is very similar. If I don't write anything, let's say this is the space, then it will give me all columns. Here also space, that means it will take all rows. Then if I want to have a look at the class, so these are the classes. So do try to do it. Transpose is a normal. For transposing, we just use T in front of the matrix. I think by this time you must have be comfortable with the basic data structures which we use in R. The most important which we'll be using are the vectors and the data frames. Let's have a look at the list. Have a look at the double square bracket. This double square bracket shows that it is a list which is made. In this, we incorporated the first entire list because x1 is written over here, and then one more vector. Let's execute this. Fine. Okay. This is one vector created as x1 where the values are from x1 to 5. Then we have x2. Then we have a data frame. in which we joined with a keyword called data.frame. And we joined both of them, and fine. So this is a data frame. It's exactly like tables. So let's have a look at the dimensions of it. In dimensions, we get 5 rows and 2 columns. If we look at only columns at a time, 2 columns and 5 rows. Next, the most important part, that is the factors, which will be requiring a lot whenever we do sentiments analytics, natural language processing. For all these kind of concepts, we need factors to be executed. Let's have a look at this. This is a very small example as compared to the one which I've used in my slide. There is a Ram word which is repeated twice. Fine. So, and the total length is 5. Now let's create the C1. So when we create C1, this is the value which we get. Now we are converting C1, which has a length of 5, to a factor. To convert it as a factor, we use a key function named as dot factor. So we convert, and let's look at the output. Please read this output very well. In the levels, it has given levels, the lower one. This lower one, only this small part. These are the unique values which we have. That means there are only 4 levels. First is Mrinal, second is Ram, Sohan and Sonali. Second time repetition of Ram is avoided here. It's not written over here. That means all your repeated values will omit and will be given as integer number. So how we look at it? Let's have a look at the class of this. Its class is not character. Its class is factor. And how it is saved? It is saved like this. Now, please have a look at in sequence to this value and this value. That means Ram has been given as an integer reference value of 2. Sonali has been given as an integer reference value of 4. Sohan has been given as integer reference value of 3. Similarly, Mrinal 1. And as we have seen earlier, Ram has been given as a reference value of 2. That's what a factor means, a difference. Let's say if we have 12 cricket players who are playing for the whole years and 40 games, about 40 games they have played. That means in our database, their name will be repeated 40 times. 12 player into 40 times. But if I convert it, all the names of player as a factor, they will be converted into unique integers, and I'll save a lot of space of mine. This is R, which is used for volume-based data, speed-based, velocity-based data. That's why these terms are important for you to understand the case. Whenever you work on any real-time case studies, you most of the time convert them to factor, sometimes to character again. And these are the important zones, strong building foundations of R as a language for analysis. So let's go a little bit deeper into this. If I have this as a vector, let's say we have a vector where the values are written as small, large, small, medium. Most of the time, whenever we asked our participants to choose from 3-4 values, we have this kind of data comes. Let's say what is, you're a teenager, or you're a mature person. If you are giving 3-4 values, then most of the time we want R to give the specification, the numbers ourselves. We want small to be given as integer 1, medium to be given as integer 2, large to be given as integer 3. Whereas in the above example, Ram was given as 2. But we never told R to give a levels as per us. But in this example, we are asking R to give levels according to us. Let's have a look at this. And integers. So it has, wherever the small is written, it is given as 1. Where the large is given, it is given as 3. So factors are internally stored as numbers. So it saves a lot of data. Your entire names, your entire data set, that's converted into numbers whenever you use factors. So let's have a look at the fetching data. As Dr. Rinku shared in her presentation, how we fetch data. Are we here to create data? No. Most of the time, whenever you study any programming language, you write a lot of commands in bringing the data. But because we are focusing on analysis part of it, the most of the time you'll find the data is already available. Whenever you have a data which is a big data, which is a dynamic data, that is never been, cannot be created as such. You cannot say that I'm creating vector in data frame and bringing the data. So for that, you bring the data in some format. Here the data is in CSV format. Let's have a look at. The moment I execute this command, you just in the lower ground, you'll find on screen that, yeah, you'll get a select window. Fine. In this, let's select a data set. So we are picking the salary data set of let's say ABC company. So this is the command. I'm just explaining you the command. Read.csv, as discussed in the earlier lecture. File.choose, because we are not giving the entire path here. We are avoiding to give entire path. For just for that, please use this function. It's a very comfortable function. File.choose. Simply the Windows command, the Windows feature of bringing which file to open, that will come. And you say this header is equal to true, means your file already has a header. I'll just show you how the file has come. It has come in a variable called as my data. And here you must have seen my data here on this my environment variable. My data, it has about 3,468 observation, 13 variables. 13 variables mean 13 columns are there. So let's have a look at how R will show you its data. This is the data set which you have. I think all can see it's there on the screen.
Yes, ma'am.
Okay. So we have a filter also here. This is the analytical language. So for everything, you need not type in, you need not go much deep. Only thing is that you're comfortable with languages, algorithms, and the functions which are there. So when I say Boston, it has given me the entire Boston data set. When I come to, let's come to something like salary. If I'll say salary, so if I'll say close the filter, okay, so this is the salary. Then we have this is all data. This is there in the file which I'm talking about. So I'm just giving an introduction. Then STR means structure of your file. Let's have a look here. This is the structure of your file. And whatever we have studied so far, let's look at that in deep. Look at the first line, data frame. It is a data frame, same, because Excel sheet comes to R as a data frame. The dollar team is a first column of it. That means it is a first vector in it. It is of type character. Then second, year, it is again of type character, and this all has been automatically taken. We have not done anything apart from opening it and viewing it. Fine. So these all are being saved as character, integer, numbers. Fine. This has been automatic. So let's come back to our screen, because we'll have to move towards the analysis part of it. So let's say if you want to say, I just want to know if from the entire data, I just want to know only about this first column team. To retrieve, to name a first column, you'll have to put this small sign in between called as dollar. Have a look. It is saying it has 1, 3, 4, 6, 8 values. This column has. Fine, and it is of character type. Mostly whenever we do big data analytics, we hardly know the number of rows there are. So we say, before we start analysis, we say, just show me the top 5. This will give me the top 6 values records of my data set. Top 6. And it is scattered in a different, because if I reduce this, it will come towards this side. If I refresh it, it depends on the screen type, how much font size is there. I've increased the font size of my screen so that it will be comfortable for all of you to read. Similarly, you can say bottom 6 records I want to search at, and summary commands. Just have a look at this command. This is a wonderful command to look at how we run for different kind of data sets with a simple command, single command, how much we retrieve. This is a summary command, and this is the first column I have. It is saying its length is this much. Now let's come to this, because it was not numeric. So only the character term is given here. Look at this. there are 9 NAs. NA, that means where there is no value is there. Maximum value is 20,000. Minimum value is 1,000. First quartile is 2. Median is 4. Mean is this. So this all information is there for numeric data sets. Are we done till this point? Okay, so let's move to our case study. And let's say we have a simple request. Whenever you do any project in R, make sure that your data is big enough. Whenever you retrieve, for this command, I want to just specify why we use these kind of points. In the my data one dot all columns. Okay, that means only first row and all columns. In the lower one, all rows and only second column. This retrieval is very, very important. Sometimes we say only pick from only pick column number 2, 5, 7. So indirectly we have made a subset of our Excel sheet. Just take this point as very, very important point. Let's say you retrieve from your marketing team, you retrieve an Excel sheet which has about 20 columns. And most of the time what I've seen in this 20 column Excel sheet, for your analysis, you pick only 5 to 6. This is a way of it. You say that all columns and only those particular columns. And if they are in sequence, you can write them in sequence. Remember to put this C here because you are bringing it as a combination of these. But if it is a sequence, you can remove this C. Let's say you can remove this C when you are saying pick all from 2 to 8. Then it's possible. Fine. Okay, so if you want to add something to your particular data sheet on which you're working, so let's say if I'll say that in this particular file, I want to add a new column whose name is new11, and then I'll say this column will be, the value will be whatever the value salary has plus 2 to it. This will create a new column, and if you want to reduce it, you can put a null to it. Fine, so I'm winding up with this because I need to start up with the case. Otherwise, we'll be a time bounded for it. Let's go for the questions round for the data types. Yes, any questions for data types?
Participants, if you have any questions, please write in the chat box.
I think I've seen first question. C is used to create vectors. Yes, the full form of C is combine. What are these sketches? These sketches belongs to you guys, bache. Then any other query till now, so that can we go ahead with the one case study? Okay, so I'm going ahead with the case study now. Okay, the case which we have taken is HR analytics. Here we have employee job satisfaction analysis using R. The entire case, as the data science courses, includes statistics plus machine learning algorithms knowledge. So you'll find a blended mode of little introduction of those statistical terms also. If you want to elaborate on any specific term which is given there, you need to study the particular term specifically from the statistical point of view. This is one case which gives you an overall look of how a particular case is solved in the real time. So the question is, the most important takeaway from this is how to convert any business problem into a statistical problems. So we need to understand a business problem. Then we need to capture the data. This data capturing includes both structured and unstructured data, and sometimes even a semi-structured data. If it is a fraud detection case, then we may need to look at the data of logs or the mail sent from one employee to the another. That means HTML data sets, the log records of our employees. So that means the data capturing includes all different types of data. Then we have exploratory data analysis, where we look at the basic terms, basic data cleaning, you can say data preparation and cleaning. Then select the best fit machine language algorithm. This is what we study in data sciences, and you can say whenever we are doing data mining, how we define machine learning is that whether it is a supervised or unsupervised or reinforcement machine learning algorithms, and selecting it for a particular case is the most important step which all data scientists needs to be aware of. We do lots of case studies just to understand which one is the best to implement on this particular case. So whenever we use any ML algorithm, we always evaluate our model. That means we check the efficiency of the model which is created. So before going ahead, I'll give you a small example because these seems to be a big word when we start working on analysis. Let's say, hello?
Yes, sir. Sir, if you're free, can I come and see you?
Hello?
Hello?
Yeah?
Okay.
Okay, ma'am, sorry for the disturbance.
Okay. So let's say manufacturing plant calls up a data scientist, or there's a data scientist who is working in a manufacturing plant, and the plant has some technical issues of, let's say it has 3-4 boilers which are placed, and the plant manager wants to make sure that if there is any issue in a boiler situation, that the information needs to be sent it to the concerned person as soon as possible. This is the business problem. And when it is delivered, or when it is communicated to a statistics or data scientist or a data analyst person, first thing he needs to do is to understand that this problem needs to be converted to a statistical problem, because a businessman is not a statistical analysis person. So he will not be able to define you what language or what platform you need to choose. So how can this data scientist can go about it? First thing, kind of data he's getting. The boilers must be having a sensor placed on them. The very first data he'll retrieve is the sensor's data. The minimum data, the maximum data, the ranges. There will be a defined ranges of the sensors or the boilers, the sensors which are placed on the boilers, the temperature, the minimum, maximum, and the highest. And these will be given, will be retrieved as from the sensors data in some of the Excel sheet format. That Excel sheet will be incorporated or will be dynamically included. It cannot be a static data because the data has to be continuous. If you want to send a message to a person for any kind of anomaly which is detected in the plant, it has to be a dynamic data. For dynamic data, I mean to say that it will continuously updating itself. It will continuously increasing, as discussed by Rinku ma'am. For a big data analytics, data has a volume and velocity. Velocity means speed, a high speed of generation. The moment we come out of a ATM, we even sometimes before it we get a message that we have withdrawn from our bank account. So that is velocity, that high speed of data generation, and we get the message. This is Spark, Hadoop's family member, Spark, which is a reason behind such a smart and active delivery of message. Same was expected from this data scientist also, to detect the anomaly which is there in the boiler. So he retrieved all the sensors data. Let's say there were 5 sensors. He retrieved the sensors data for all the five boilers, and he analyzed and put a small message that if the sensors value goes a particular ahead of particular level, then a message is to be sent to 3-4 responsible persons. I think that's how he converted that small business problem to a statistical problem. So first step, understand the business problem, because here no system or no automatic things will be going on. This is as a data scientist or as a data analyst, we need to understand the business problem. Then we need to know how we'll capture the data. Will the captured data will only be structured, or it will be unstructured also? Then how we'll prepare that data or clean that data before we execute any machine learning language on it. And finally, to check whether the model which we have used for predicting, or let's say for that plant, or for the average which that data scientist has used to check the boilers values, that is being taken as correct or not. That is the model evaluation part. So let me give a statistical term to everything which I have defined so far. First, understand business problems, understand the objective. Let's say whether it's any senior member or a team leader who has given you the problem, just understand his objective. He needs messages, dynamic messages. It can be a WhatsApp message or it can be a message on ERP. It can be a mail. Please understand that. That's what you need to understand, where the output will go. Second, gather relevant information about the problem statement. As a data scientist, you may not be knowing the status of boiler, which is considered as normal. So please learn it from the person who is managing it at present from the ground. Then data capturing, gather data, both structured and unstructured data. Then we have EDA, where we have to go for bivariate and multivariate or univariate analysis. Data cleaning, data splitting. We may need to divide the data. Whenever we are using machine learning languages, we are always supposed to split the data in training and testing. Then feature engineering. And for ML language, for machine learning algorithm, we have regression, classification.
Hello, sorry to interrupt, ma'am. Ma'am,
Yeah.
are you sharing any screen?
Sharing any?
Screen.
Yeah.
Ma'am, it is not visible.
Just hold on. Thanks for informing.
Listen. Ma'am, please continue.
Is it now?
Yes, ma'am.
So I covered this. Fine. This is the first one. Is it visible now, screen?
Yes, ma'am. Yes, ma'am.
Now this is where I was. So select best fit machine learning algorithms. It can be regression, classification, clustering. These are just few names. Association rule mining. Then we need to evaluate our model, check how the prediction, whether prediction is accurate or not. We need to check the performance using some basic ROC or AUC curves. So now let's look at today's case, which we are doing. This is a business problem. Let's say we have Mr. Kunal, who is working as project in charge with Sun Infotech Limited. It is an IT infrastructure company. So there are few issues he faced and shared. That is, the quality of work is suddenly declining, increase in error rates and pending work of the employees. And there is a lot of absenteeism and attrition on rise. So the major question which he had in his mind is whether the employees are satisfied, why there is a quality work declining, why there are so much pending work, why the absenteeism is on rise. So this is how the business problem comes. And once the problem comes, you need to discuss and you need to look at the areas through which you can solve it. So the very simple step which we are using here at present, as most of the time we don't know how to get the data. If the data is already there in the market, whether that secondary data we can use it in our research or not. Like in a case of COVID-19 research data which we have, this is available in on different websites, fine. But not every data. If you're talking about only your organization, specifically in a critical zones like HR, you'll not get data which is online, or you cannot get retrieve data which is of HR department itself. They'll not be sharing that because it will include a lot of information. And your question is pretty different. You're asking about job satisfaction. So step one is use a questionnaire. Fine. So you can decide on this particular example has 30 questions. This depends. This is an answer to the question. Most of the time people ask it's been 4 years that I and Rinku, we both are taking data analytics courses. And most of the time we get this question that how we should get data, how we generate a primary data, create it yourself. Like if you want to look at any problem, let's say if you want to look at the feasibility or the efficiency of online teaching, you need to create a questionnaire. Or to create a questionnaire, you have various platforms. Fine. Decide on the questions you want to ask, and you can give a 5 demographic variables, like whether you are satisfied. This particular question has these 5 demographic variables: very dissatisfied, somewhat dissatisfied, neither dissatisfied nor satisfied, somewhat satisfied, and very satisfied. The survey type is a Likert scale. 5 because we have 5 demographic variables. Whenever you have a survey in which you have defined the parameters that I'll judge from on a scale of 1 to 5 only, then it's a Likert scale. Then let me show you the sample questionnaire. Okay. Is the questionnaire visible on screen? Is the
Yes,
question?
ma'am.
Yes, okay.
Yes.
Have a look at this. This is a normal questionnaire, job satisfaction survey. So we have few basic questions like of the job location, experience, education, functional domain of the person, gender. They are the few basic questions. Then these are the basic questions we want to ask. Have a look at the questions. They are, they don't ask directly. No one asks you directly whether you're happy in the organization or not. You'll have to make it in a different, like a psychometric test. You'll have to ask in it 3-4 ways to retrieve the same answer. Let's say question number 1. I clearly understand the strategic objective of my organization. And question number 2, say I can clearly explain my role. Sometimes you understand the objective of organization, but you don't understand what role you play in that. Fine, but both of them are talking about the objectives of the organization. Then you'll have to go little deeper into it. That let's have a look at this question. My organization has well monitored process which simplifies access to information required to make better decision at work, very transparent, less time consuming. So this is about 30 questions which are asked from each employee of the organization to understand the job satisfaction. So I'm coming back. That was the sample questionnaire. Okay. What is univariate analysis? When you're talking about one variable only. Let's say question number 1. What values you get in it? You are only working on that one numeric variable. In a univariate analysis, first you talk about numerical variables in which you can find mean, median, mode, variance, standard deviation, quartile, skewness, histogram, and bar chart. But if it is a categorical variables, that means let's say we have 3 categories: happy, very sad. So in this categorical variables, we'll have to find count. How many of you are happy? How many of you are sad? Then percentage. What percentage of people are happy? And to display it, we usually use pie chart or a bar chart. Then a second phase called as data cleaning. Data cleaning may be answer to the missing values. We say, let's look at the missing values and assign a values to it. There are different ways or how we handle missing values. This is a special part of statistics which we read separately, that how to, what is a treatment for the missing values. This depends on the data scientist. Then the outliers. Sometimes we say that all students in my class are usually within the age range of let's say 15 to 25, but 3 students are of 30 and 3 students are of 10 years of age. So these 6 students which I talked about, they are outliers. Before we start processing or before we go towards the machine learning algorithm, we should address these, how we'll handle, because they will variate. They will make a big difference in your data. They'll change your mean values. So we need to handle missing values. Let's say you take a survey, and in this survey, most of the people didn't answer all questions. So all those missing values which you have, they will create issues. They will not let your machine learning algorithm predict in a fair way. So please handle. Data cleaning is an important step and the most important step. Missing values are to be handled and outliers are to be analyzed and needs to be decided how we'll handle it. Okay, so then we have a feature engineering. Feature engineering means, let's say this questionnaire has 30 questions. 30 questions is a big number to talk about. 30 questions means whenever you are going to find a mean, you'll be getting 30 means, 30 medians, 30 mode, 30 variance, 30 standard deviations. So we need to reduce them. We need to reduce them to some level that think those questions who are asking the same question in the different formats, they should come as one factor rather than taking as different variables. Then we need to transform few data. Yes, this is again an important point. We need to transform our data mostly. The data transformation can be normalization, standardization. We can use log, we can use square roots for it. Then in a dimension reduction also, we can use factor analysis, we can use principal component analysis, we can use multicollinearity concept. This decides on the data scientist decision. Then for variable creation, we can create a derived variable. Let's say you have given your date of birth and I'm deriving the age out of it. That's a derived variable. Then we can create dummy variables for like, which I created in my recent my salary data sets. I said, okay, give plus 2000 to all. So that was a dummy variable. So derived is when you already have a variable, but you are deriving information out of it. So feature engineering means you already have a data, but you are deciding whether you will be taking all of them together or you will be reducing few of them. For reduction, that means for dimension reduction, we have techniques such as factor analysis. I'm repeating this part, factor analysis, because in this particular case, we are using factor analysis. But apart from factor analysis, we have principal component analysis. It's widely used. We have multicollinearity, VIF also. We can use that also. And for data transformation, we can go for normalization, which is usually done. Then log also, we can use square roots, and we can use basic standardization. Okay. Whenever we create a questionnaire, we created a questionnaire which has 30 questions. We are supposed to check the reliability. That is a reliability check of the questionnaire. It is a measurement to check the accurate representation of factors or variables. The first one is test, retest, check. When you use the same survey, the same survey is given to people and the results are compared at two different points, that is test and retest. Then we have a parallel forms. When a group of people complete two similar survey and each survey uses a different statements. Then we have interconsistency check, which is average interrelated correlation, or a split half can be used for it. We are using internal consistency check for our case, right? Then we have inter-rater also. Basically, reliability is calculated for responses only. For only responses, we usually remove demographic variables whenever we go for a reliability check. The reliability check which is used in this case is based on alpha values, and anything above 7 is considered as acceptable for it. So I'm coming to the R script now. Is the R Studio visible?
Yes, ma'am.
Okay, so we are coming to the case study now. This is a job satisfaction analysis, and we are using the factor analysis for it. For very first thing, which we have already done in our earlier example also, we'll choose a file. Control enter here, and we'll say data set. Let's say we are using a workshop data set at present. It has been saved in a file in a variable called as data. And if I want to view it, so this is the data set. Name of the variable is data. This has 1400 observation and 35 variables. 30 are our questions which we asked, and we have these all values for our demographic one. Demographic mein, we are asking about department, experience, age, gender, education, and have a look at, because we said that it has to be on a scale of 1 to 5. So all our data is in scale. This is where the reliability test has to be done whenever we are using these scales. This is a Likert scale which we have used for. This questionnaire is based on a Likert scale. So let's start. So we imported our CSV file. Are we done till this point? And the moment we check, the first one is, let's check the number of rows and columns in our file. Dimensions. Dim is for dimensions. Fine. So dimension is 1400 rows, 35 columns. The top 5 rows. This is the top 5 rows. Tail is for, we are looking at tail, top 10 rows. Structure. This is an important part. It's very important for a data analyst to look at the structure before he starts or she starts working, because from here he'll understand the data. In the earlier which example I gave, there were no factors, because by default R will not convert any of the data which is coming from any format into factors. Either it will be character or it will be int or a Boolean type, basic types. So we have a department, we have experience, age, gender, education, and the other variables which are storing the questionnaires, questions which we have given. These names are been given from our side because the entire narration of the question was here, which I removed and I converted them into variable names. So let's proceed. This is the structure. For finding the structure, you'll have to just use str. That's it. Now comes to univariate analysis. Univariate, that means we are talking about a single variable at a time. So whenever we go for analysis, I don't think we need to analyze those 30 questions which we have asked. We need to summarize only the values which are demographic. That means demographic may we have these 5 which are demographic. Let's understand only 5, the upper one. Have you noted this 1, 6, 11, 16, 21 which is coming? Just look, and this is the first, this is second, this is third, this is fourth, and this is fifth. So here comes the sixth. If your font size is high, then it may come to as till this point it's shown and it will be coming as 4. So it may be different on your screen and it is different on my screen. So let's have a look at the summary. Okay. We'll pick only the demographic data. That means we are saying only first to 5 columns are to be used, and let's find out the summary of it. Okay, understand the summary. We'll say department has a 1400 characters, and they all are being saved as a characters because they are not being changed as the labels. So the same thing is coming. So we used a command called table to find out the data in this. Have a look at what a table command do. This is output of what this small function do. There are 3 values: HR, research and development, and sales. 3 values which are there in the department. So we have 61 HR people, 917 R&D, and sales maybe have about 422. And if you want to create visualization is an important part of R. So let's see if you want to create a visualization of number of staff members in each department. Similarly, it's been shown for education, for experience, for age, for gender. Okay, so let's have a look at this. This is for a percentage to be shown rather than this. So we are getting only the percentage part of it. This much percent, 65.5%, 30 point. This is only conversion of the same, and rather than giving this, we can only give in the conversion part of it, matrix for it. Now let's come to data cleaning part, which I've just shared. As this particular session is focused more on the overall explanation how the data analysis is done in R. So the data which I have taken, there is no missing value in it. Just have a look at this command. I asked, is there any missing values? NA is for a missing values. Is there any missing value in the data? So we don't have any missing values. So data cleaning is the one which is not a part of this particular session. So next thing is, we'll say, let's have a look at, this is the structure of our data. We have all questions, survey questions are in integer form. So explicitly we are declaring all integer types as categorical variables. Whatever we have received from our survey in all the 30 questions is a range from 1 to 5. So the next question which arises for our analysis is how many checked for 1, how many said 2, how many said 3, or how many said that we are neutral for the answer. So for this, we'll use a small function called lapply, which will convert all the 30 questions which are saved as numbers into factors. Let's have a look at. An important step to use the features of R. Please understand this output very well so that you'll be able to answer why R is being used for this analysis. The first one, department, says 3 factors, 3 levels. That means there are 3 departments, which we have just seen in the earlier commands: HR, R&D, and sales. Experience says there are 4 levels. That means the questionnaire had 4 levels defined: range, age. Again, it was within the ranges. Gender, 2 levels. Education, 5 levels. Fine. And all variables which we were earlier using it as int are being converted as 5 levels. That means now when you'll use a table command, it will be giving you a summary of how many candidates are there in that particular levels. Let's install. Okay. One more thing, you learned about packages earlier. So let's have a look at whether we have a summary tools package at present. Yes, we have. But if you don't have this package, go to package, go to install, and summary tools, which is written over here. Just start typing it. It will give you. Type in that. Always say install dependencies and simply install. Just have a look at the R library, the version in which you want to save it. And as I already have, I am canceling it. So this is the command which is a part of this particular package. Let's have a look at. Let's understand the output of this command. A very interesting command. Those who are into analysis, they'll be able to see how efficient it was. Okay, now have a look at. So let's look at gender. We have 40% female participants for our survey, and we have about 60% male participants for our survey. Then let's come to our basic questions. For our first questions, most of them, I think the biggest letter lies in 21, I think, 21, which is, I think, somewhat satisfied, 21%, but the margin is not very big. So this is how we analyze this DF summary, and these all are automatically done. You need not write a big codes for it. You need not write a big loops for it. It's simply install package. Those packages already have the functions defined. You need to understand the package first, and to understand or to know more about the package, you can go to Google and you can say R package for summary tools. Fine. You'll get a lot of introduction. So that's not a big deal at all. So please focus on that. Only thing is packages. As new packages comes, try to understand them. This particular step is check the reliability of the survey which we have made. For this, we have used a package called as PSYCH, PsychCH. That is a psychometric test, because the questions which are defined asking the same thing in a different form. So we need to have a psychometric package installed. For this, sometimes as I've heard from many of my students that this particular package don't work on their system, please install the R version, which is higher to 3.6. Don't install the package directly from or update the R version directly from RStudio. Go to R, load install R there, and then upload it. Fine. So I'm coming to the next part because we are short time. Okay, dimension reduction. So in this psych package, you have the analysis part of it. So let's need to install the package. If you want to execute 3-4 commands simultaneously, you can use this. You can simply select all of them and press Control Enter for it. Okay. Okay. Let's have a look at the screen. This is called a elbow method. It tells you how many factors you want to create. Like from 30 questions, I need to create how much factors I should create to get a good results from my survey. So whenever you get a some stuck on line after which stability comes in the image, fine. That means somewhere around 9 or 10 I can fix up. So in the next command, I fix that number of factors I want is 9. This is the main output of our analysis. Have a look at this. We have variable 1, 15, 6, 7, then 30 and 2. They all are somewhere related to each other and is being kept in a one factor called MR1. This is an important one to understand, that this is automatically being derived. Let's have a look at what it means. Okay, that means this factor 1 has included these questions, these 6 questions. Kindly have a look at these questions. The first question talks about the strategic objective of my organization. The second question talks about achieving my company's objective, whether I understand my role or not. The third, my organization has fair and transparent system for promotion for all employees. Seventh question, I think management is just towards administering policies concerning employees. If something unusual comes up, I know how to approach at workplace. The organization informs me about all the responses, resources and tools to perform my duties well. That means your entire psyche package has analyzed your 30 questions and given you the answer that bring all these 6 questions as one factor. Factor means group of questions. Factor is simply nothing more than grouping. So whenever you say that I have a factor analysis which I have done, it simply groups that particular part. It has grouped these 6 question answers for one part. That means when you say I have analyzed, you said you can easily say that company objective and policies has this much satisfactory or unsatisfied employees. Now we are returning back to the one which we did earlier. Now let's understand this. We covered till the reality check. Now bivariate analysis. Bivariate means when we have, let's say, marks in maths and marks in science. We have 2 columns. Students' marks achieved in maths subject and students' marks achieved in a science subject. So we need to find the interrelationship in between, or in a statistical term, correlation among them. We use a chi-square test, which is an important step to check whether we should proceed ahead or not. Chi-square test is already been done, is already been shown there in the script, but I didn't execute it because of time constraints. It is a commonly used for testing relationship between the categorical variables. Fine. A null hypothesis of chi-square is that no relation exists, whereas the alternate hypothesis says there is a relation in between. We have used factor analysis. As our diagram has just shown in R, that there are 9 factors which we can use. And these 9 factors are been derived, the number of factors has been derived using the elbow method. So factor analysis is a technique that is used to reduce a large number of variables into a fewer number of factors. This technique extracts maximum common variance from all variables and puts them into a common score. It is an important tool for investigating variable relationship for complex concepts as employee satisfaction, socioeconomic status, and psychological skills. Widely used, this factor analysis is widely used in market research, HR research, business service. It is a useful tool when we use a socioeconomic, dietary patterns, and psychological scales. The key concept of factor analysis is that multiple observation variables have similar patterns of response. For example, when people may respond similar to the questions about income, education, and occupation, which are all associated with the latent value. Latent value is an information which cannot be explained by a single variable. But observed variable is the one where we can directly use a meaning for it. And factor means a group of such variables. Here we use a eigenvalue is being used. Fine, and this is what we finally combine. This is only a one factor which I've shown in my slide. Rest factor we'll see in our, just hold on. Is the R Studio visible now?
Yes, ma'am.
Okay, now have a look at the screen. How many factors which we have retrieved from our analysis? We have retrieved 9 factors. Look at the variable 20, the last lower one, which is not related to anyone. Last one. That means this was the question which was different and was unique. Rest all combination is been made by R itself. And we have used simple psych package for the same. And how we take insights from it. Let's analyze the interpretations. The last part of today's session. We had 5 values on which we were working on. At present, now we reduce them to P1 as non-satisfied employees, P2 as neutral employees, and P3 as satisfied employees. We'll convert all 5 scales into 3. Fine. That means highly agree and agree will come to satisfied. Highly disagree and disagree will come to non-satisfied, and rest all to the neutral. Okay, so these are the variables we have for the first factor. For the first factor, we have 1, 15, 6, 7, 30, and 2. Question number, these are questions from our questionnaire. So we'll pick all of them. We have picked first, second, 6, 7, 15, and 30. And we are just looking at the table of them. Let's have a look at the first one. And we'll take a sum of them in F1. You want to have a look at? Anywhere you can write in and control enter, you'll get the look at. That means we have first one. That means highly dissatisfied is 1500 something. This is in all the questions, the total of all the questions. Now we are converting it to a matrix and calculating the percentage. Let's scale them to let me explain this. Here we are using a 3 scale responses only. We are converting our 5 scales to 3 scales. These are neutral. These are disagree or agree, disagree and highly disagree, then satisfied and highly unsatisfied. So let's have a look at the output which we have received. So this is the output which I'll be sharing with the management, that we have about 37% employees who are unsatisfied with the policies of the government, of the company's objective and policies, whereas we have neutral candidates about 21%, and we have satisfied of about 42% of our employees who are very satisfied from the company's policies. So this is only a one factor on which I've explained. We have 9 more factors on which the explanation can be made. So insights are derived, although this has the information about all. but I'm just explaining how these factors are used to take insight from the survey which you have taken. Very first step which we did is to understand the particular single variables. That means a univariate analysis of demographic values. That means how much education, what was the age of people who gave the responses to our survey. That was the first step. In the second step, we went for data cleaning, in which we have a dimension reduction, and then we look at the missing values. We handle the outliers also. Then we go for bivariate. Bivariate means there is a interrelationship among the two variables or more than two. Then we come to checking the reliability of the questionnaire which we have made. And then we finally reach to a factor analysis. And for factor analysis, we need to look at the number of factors we want to talk about, the factor loading, factor extraction. We have used OLS for the same. And finally, we derive output out of it. This is the final output which we retrieve. And this is, I have not written a narration about it, that this is the first one. That means factor 1, which talks about the company's objectives, is been given. The output has been narrated as this, that about 37% of employees are non-satisfied with the organization objective and fair policies, whereas about 42% of employees are satisfied with the organizational objective and fair policies. So that's it from my side for the case study. Very small explanation. Rest you can have a look at when you go for M2. It again has the questions which it talks about. Once you look at those questions, then you can look at what is a title which you can give to it. Let's say, for example, for this question, for the next question, we have 12, 10, 22, 17, and 5. These are the one which are to be brought together, and we can find out that the company's, this factor has answered to these all questions of my questionnaires. So now I would like to handle any questions which I have from the viewers. Already crossed the time. Yes, any questions in the
chat box?
Yeah. Yes. Is there any text? Yeah. Is there any textbook for data science using R? Yes, there is a book of Gardner, but make sure there is a very thin line when you talk about programming in R and data analytics or data science in R. So look for more industry-based case studies rather than looking at programming questions like you need to find a leap year or something. Whenever you buy a book for R, look at that the case studies are more towards business problems. Please share some tutorials for this. Okay, this you can connect, and you can. I think the organizers can deal with this. That they can contact me for any tutorials if required from the participant side. Can R work on image data database also? Yes, but you need to look at the packages which are to be used for it. The entire GPS packages which are there, there can be a, I think today's session was more towards only a brief introduction, because whenever you talk about a big term called as data science, you need to be good, you need to have efficiency in statistics plus machine learning algorithms. So as the example which has been shared today has just the elementary type of it, because even if I'll talk about predictive analytics, you need to be comfortable with regression, because logistic regression, linear regression, they are the one which makes a platform for predictive analytics, which is in high demand. So what is the difference between data analytics and data mining? Wonderful question, Beta. Data analytics is more towards analyzing. Data mining is a part of it. When I talk about machine learning, okay, I'll give you an example that when I say predictive analytics, I'm talking about linear and logistic regression, fine. But when I talk about machine learning, I include data mining techniques also. Like when I say clustering, it is a data mining technique, which is more or less in a computer science engineering courses, but is taken here in a data science profile also. And machine learning is an overall very big word, which includes your statistical techniques also, your data mining techniques also. So all these algorithms, when they comes and they can help the business in solving the business problems, we call them as a data science problems. and we use them as data science techniques. So both statistical, data mining, they all are part of data science algorithms or machine learning algorithms which we use. Any other question, beta? Any other question from any participant?
Participants, if you have any questions, please write in the chat box.
What are the requirements for data science courses? Flair for numbers. You should be happy with numbers. I think in this field, I think it's been 4 or 5 years in this field, and what I've seen in my classes also, that there are students who are in fear of big numbers. Whenever we talk about data science, it definitely goes towards big data analytics. So your number goes as the volume. Most of the time, your Excel sheets cannot accommodate them. That's why we use Hadoop. So you need to be comfortable with numbers. Let's say if I'll say that as a teacher, I got a Excel sheet of 500 students data in my Excel sheet. It's okay, good to see and good to find mean, median, mode, standard deviation out there. But when it comes to 50 million record sets, you cannot even take a printout. So that is what this field is all about. You cannot see the entire data set on screen. It's a summary tools only which helps you. The summary tools which I was using in R at present, they are the only helping hand which you have to analyze your data. When I say that I use a head command or tail command to understand my data, because I cannot see that entire data set. I cannot say that I took the printout of 50 million viewers on live on my particular ABC site. So that's what is big data analytics, and that what is data science is all about. When I say data science, it never actually fully says that I deal with volume. It only deals with machine learning algorithms. But when I say big data analytics, then definitely Hadoop is a big player. And your apart from SQL data sets, no SQL data sets comes into the focus. Give a real life example for each data analytics and data mining. Okay. Okay. Let's say that data mining and data analysis. Okay. Let's say that suddenly I got this message that I have let's say we have a 4-floor building in which we have about 400 students who are studying in a particular ABC building. And suddenly we get an information there is a possibility of earthquake, and all 400 students are required to take buses and leave the campus ASAP. So at that particular time, what you need, how you send a message to all students that there are 6 buses or 5 buses outside, go and sit, they'll help you in, one bus will be going towards north of Delhi, one will be going towards south of Delhi. How will you say? Because students make a havoc of how they'll go downstairs and how they'll take the bus, and maybe they'll take a wrong bus going. If the person wants to go towards south, he may go in the bus which is going towards north side. So I think in this situation, what helps you is algorithms. As a data scientist, man, it's a minute job. He'll pick the data or database of entire students, even if it is an Excel sheet. He takes up the roll number of the student, phone number of the student, and address. And the address on the basis of GPS location, he'll divide it north, east, south, west of the Delhi, and you'll get a WhatsApp message on your phone that you'll have to take this particular bus among from the buses which are standing outside, and you need to take this bus to reach your home ASAP. So this is data mining. What he has done, he simply used a clustering algorithm which is defined in data mining techniques. But if he is a computer science child, he is very comfortable with data mining. But when it comes to data analysis also, he will talk a little different in it. He'll be able to predict also that there are few students who will not take bus even with the 3 reminders, because he'll be using the older data sets predicting behavior of the child, sentiments analysis of the child. Then one more key terms comes into light called as data visualization. This data visualization is a thing which makes the job of data scientist very creative. Because if I give you output of, let's say beta, I'll give you output of predictive analytics, then it will be very boring for you to see that yes, these are the numbers which are given in sequence to me. But if I'll draw a diagram, it will be much more understandable for even a layman. So visualization terms also come when you talk about data analytics. It is a combination of statistics, data mining, and visualization. I hope I made a justice to your question. Anything else? Any other query?
Any other questions, participants? Okay, ma'am, I think that's it.
Okay, thank you. Great going. Thank you. Thanks to all of you.
It
God
was
bless.
really very
Thank you.
informative and interesting session, ma'am. We really had great learning throughout the session. Thank you for sharing your
Thank
time
you.
and knowledge. Thank you, ma'am.
Thank you. Thank you all.
Okay, so we have a break here, and as we had some changes in the schedule, the next session would be taken by Dr. Karan Singh at 2:30. So I request everyone to join again at 2:30. Thank you all.
गांव का है?